Hello there, and welcome to Life Beyond Scene, where curiosity gets cozy, strange stories settle down beside science, and even the darkest corners of the map are allowed to speak softly for a while. Tonight, we are drifting toward a place that has lived in the public imagination for more than half a century, not because it is hidden from the world, but because it is right there on the map, crossed by ships, flown over by planes, watched by satellites, studied by experts, and still somehow able to make the mind pause. The Bermuda Triangle. A stretch of the western North Atlantic often drawn between Florida, Bermuda and Puerto Rico, though, rather inconveniently for anyone trying to be dramatic with a ruler, its borders are not officially fixed. It is less like a fenced-off danger zone, and more like a story people have drawn over the ocean, again and again, until the lines began to feel real. And yet, even if the triangle is not marked by warning lights on the water, even if pilots do not generally avoid it as if it were guarded by sea monsters with clipboards, the name still has a certain chill to it. Say, Bermuda Triangle, and suddenly the room gets a little quieter. You may imagine a lonely ship radio going silent, a compass needle turning in a way it should not, clouds gathering too quickly, waves lifting out of nowhere, or an aircraft disappearing from radar while someone, somewhere, is trying very hard to sound calm. It is one of those mysteries that almost everyone has heard of, even if the details have become a bit foggy over time, like an old photograph left too near a bathroom mirror. Before we go any farther into these waters, I'd love to know where you're listening from tonight. Are you somewhere near the sea, where the sound of water is ordinary and familiar? Are you far inland, with the ocean existing mostly as a thought, a holiday memory, or a place on a weather map? And if you have ever crossed the Atlantic by air or sailed through open water, did you find it peaceful? Or did some small part of your mind look down at all that blue and think, well, this is beautiful, but it is also a very large place to misplace a person? That may be the real reason the Bermuda Triangle still holds us. Not because it proves monsters, aliens, lost cities, or secret portals are waiting between the waves, but because it points to something we already know and often prefer not to think about. The ocean is enormous. The sky above it is enormous. Human machines are clever, strong, and covered in switches, but they are still moving through a world that is much older, heavier, and less interested in our schedules than we would like. A ship can be large enough to carry hundreds of people and still become small once the horizon closes around it. A plane can be full of instruments and still depend on fuel, weather, visibility, communication, and the ordinary good fortune of everything working at once. That is not supernatural. It may be more unsettling than supernatural because it is real. If you find this kind of slow exploration soothing, strange, or simply a good way to let the day loosen its grip, I'd be very grateful if you gave the video a like and subscribed. It helps this quiet little corner of the internet reach other people who enjoy science without shouting, mysteries without panic, and bedtime stories that may occasionally mention rogue waves, which are not ideal for sleep, I admit. But we shall discuss them very calmly. And as always, I do hope this is interesting enough to keep you company, but not so interesting that you find yourself wide awake at 3 a.m, checking whether your houseplants are aligned with magnetic north. That would be understandable, but perhaps unnecessary. So, settle in. Let your shoulders drop a little. Let the room around you become ordinary and safe. We are not boarding a doomed ship tonight. We are not stepping into a thunderhead. We are simply looking at the story of a place, how it formed, why it grew, why it frightened people, and why scientists, even when they reject the wildest claims, still find the real conditions of that region worthy of respect. The Bermuda Triangle has been called many things: a graveyard, a trap, a mystery zone, the Devil's Triangle. That last name has done a lot of work over the years, mostly because humans are very good at taking uncertain geography and giving it a dramatic title. The moment a place has a name like that, it stops being just water. It becomes a stage. Every incident inside it starts to feel connected, even if the same kind of incident somewhere else might be filed away as bad weather, bad navigation, bad luck, or a very regrettable day at work. A missing boat off another coast might be a tragedy. A missing boat in the Bermuda Triangle becomes evidence. This is important because the triangle is not a laboratory with neat walls. There is no official switch you pass where the normal Atlantic ends and the mysterious Atlantic begins. Different writers and storytellers have drawn it differently. Some make it smaller, some make it enormous, some include the Bahamas, parts of the Caribbean, and broad routes used by commercial shipping and aircraft. If you draw a large enough shape over a busy enough stretch of ocean, you will inevitably capture accidents, disappearances, storms, mechanical failures, navigational mistakes, and stories that arrive without all their paperwork. The ocean does not need a curse to be dangerous. It has weather, depth, currents, darkness, and distance, which frankly are already doing plenty. And yet, there are cases that helped build the legend because they were genuinely frightening. Not frightening in a cartoon way, not with glowing tentacles rising politely beside the ship, but frightening because of silence. Silence is one of the great engines of mystery. A vessel sends no clear distress call. A plane is lost after confusion over position. Wreckage is not found, or not found quickly, or not found at all. Families are left with facts that do not connect into a satisfying shape. Investigators can suggest likely causes, but likely is not the same as certain, and where certainty ends, imagination moves in, takes off its coat, and begins rearranging the furniture. Think of how different a story feels when it has an ending. A storm struck. The engine failed. The crew made this decision. The wreck was found here. That is terrible, but it has edges. People can grieve around it. Now think of a disappearance with no final position, no wreckage, no last explanation, only a route, a time, a name, and then nothing. The human mind does not like nothing. It will fill the empty space with theories, because theories are easier to hold than absence. A strange light is easier than a missing body. A magnetic anomaly is easier than accepting that the sea can hide evidence with a patience we cannot match. This is where scientists and storytellers often part ways, though not always as sharply as people imagine. A scientist does not need to believe the Bermuda Triangle is supernatural to find it serious. In fact, the serious part is usually the natural part. Sudden storms can build over warm ocean water. The Gulf Stream can move swiftly enough to carry debris away from where a search team expects it to be. Shallow banks can rise near deep channels, creating complicated waters. Tropical systems can develop and change conditions quickly. Human navigation, especially before modern GPS, could become uncertain over open sea. Small mistakes can grow when there are no road signs, no landmarks, and no helpful person at a petrol station telling you that you should have turned left 20 miles ago. The region is also busy. That matters. A quiet pond with 3 boats a year will probably not produce many legends, unless one of the boats is crewed by unusually dramatic ducks. But a major area of ocean near the southeastern United States, the Caribbean, and routes toward Bermuda sees a great deal of traffic. More traffic means more incidents. Not because the place is enchanted, but because probability, like a tired accountant, keeps doing its job. If enough ships and planes pass through an area over enough years, some will encounter trouble. If that area already has a frightening reputation, each new trouble seems to confirm the old story. Still, there is a difference between saying the Bermuda Triangle is not proven to be unusually deadly and saying there is nothing to learn from it. That would be too simple. The triangle remains interesting because it gathers together many things that make sea and air travel vulnerable. Weather, navigation, mechanical reliability, communication, human judgment, ocean currents, waves, and the difficulty of search and rescue all meet there. It is a kind of public classroom, though one with rather poor lighting and far too much water. Scientists may not be terrified of the triangle. as a magical place, but they are very aware of how dangerous ordinary nature can become when several risks arrive at once. And that word, ordinary, deserves a moment. Ordinary does not mean harmless. A hurricane is ordinary in the sense that it belongs to nature. So is lightning. So is a wave taller than a house. So is a current that can move wreckage before anyone knows where to look. So is human error after fatigue, stress, confusing instruments, or poor visibility. The natural world does not become less dangerous because it is explainable. In some ways, explanation makes it more sobering. A monster can be imagined away. Bad weather cannot. A curse can be laughed at. A fuel calculation cannot. A legend may fade, but physics continues turning up to work. Perhaps that is why the Bermuda Triangle still terrifies people who know better. Not because the evidence points to one giant hidden cause, but because the real causes are familiar, scattered, and difficult to defeat completely. No matter how advanced our technology becomes, travel still involves trust. You trust the engine, you trust the forecast, you trust the instruments, you trust the person reading them, you trust that a small issue will remain small. Most of the time, that trust is rewarded so routinely that we forget it is trust at all. We sit on planes, watch clouds pass, sip something from a plastic cup, and feel mildly annoyed if the snack is disappointing. We do not spend every minute thinking about altitude, pressure, fuel, or the great dark ocean below, because if we did, air travel would be less transportation and more a group anxiety exercise with seatbelts. But the Bermuda Triangle invites those thoughts back in. It asks what happens when the systems we depend on fail, quietly or all at once. It asks why some emergencies leave clear trails and others leave only questions. It asks how much of a mystery comes from the event itself, and how much comes from the way the event is remembered. It also asks why we are so drawn to places where knowledge feels incomplete. Because humans do love a gap. We may complain about uncertainty, but we also gather around it. We make documentaries, books, maps, late-night conversations, and videos like this one. We say we want answers, and we do, but we also want the feeling of standing near the edge of what is known, provided there is a warm blanket nearby and no immediate need to operate a radio. There is also something strangely personal about the Bermuda Triangle. Most famous mysteries sit at a distance. Ancient ruins, deep caves, distant planets, locked archives. But the Triangle is part of a modern world of travel. It involves ordinary routes, working crews, training flights, cargo vessels, private boats, holiday waters, and places people still visit. Bermuda is real. Puerto Rico is real. Florida is real. The Bahamas are real. These are not mythical corners beyond the edge of a medieval map where someone has drawn a dragon because they ran out of coastline. These are places with airports, beaches, families, weather reports, and very normal people ordering lunch. The mystery sits beside the ordinary, which makes it harder to dismiss emotionally, even when we understand it rationally. The legend also grew during a time when media could carry fear faster than careful investigation. A disappearance at sea might begin as a report, become an article, turn into a book, and eventually settle into public memory with details sharpened in some places and blurred in others. The story becomes simpler as it spreads. Ships vanished, planes vanished, compasses spun, no wreckage, no explanation. That version is easy to remember. The fuller version is slower and less tidy. It includes weather records, maintenance questions, training histories, navigation uncertainty, search conditions, conflicting reports, and sometimes the uncomfortable phrase, unknown but probably not impossible. Unfortunately, unknown but probably not impossible does not make a very exciting poster. And yet, for our purposes tonight, that slower version is exactly where the fascination lives. Not in proving that every wild claim is true, and not in flattening the whole subject into nothing but exaggeration, but in walking carefully between them. There are myths here, There are misreported details here. There are cases that probably have ordinary explanations. There are also genuine losses, real people, real fear, and real environmental hazards. To treat the Bermuda Triangle only as nonsense misses why it became powerful. To treat it only as supernatural misses what the ocean can actually do. So we will let the story breathe. We will begin with the legend itself, because legends are not just mistakes. They are records of what frightens a culture. Then we will move through the famous disappearances, not to exploit them, but to understand why they echoed so loudly. We will look at the geography of the region, because maps matter, especially when a place becomes famous for being hard to explain. We will talk about compasses, magnetic variation, storms, waves, methane theories, aircraft, human decisions, and the very practical problem of finding wreckage in a moving sea. We will also return now and then to the quieter question beneath it all. Why does this story endure when so many experts have argued that the triangle is not statistically extraordinary? The answer may not be that science has failed. It may be that mystery is not always removed by explanation. Sometimes, understanding the pieces makes the whole thing feel even more impressive. A wave does not need to be supernatural to be terrifying. A storm does not need a personality to change lives. A compass does not need to be cursed to confuse someone at the worst possible moment. And an ocean does not need to hate us to swallow evidence. It only needs to be deep, wide, and moving. For now, picture the map in the simplest way. To one side, the coast of Florida, with its ports, beaches, and busy skies. Far out in the Atlantic, Bermuda, sitting alone compared with the crowded islands farther south. Below, Puerto Rico and the wider Caribbean. Warm waters, trade routes, reefs, storms, and long histories of travel. Between these points stretches a region that is not empty, but it can feel empty once you're inside it. From above it may look like blue glass. From a cockpit it may look endless. From a deck at night with clouds covering the stars and the radio quieter than you would like, it may feel like the world has narrowed to the sound of the engine and the dark line where water becomes sky. That feeling is not evidence of anything strange, but it is the soil where strange stories grow, and the Bermuda Triangle, more than almost any other modern mystery, has grown very well. The legend did not rise from the water all at once. It gathered slowly, case by case, headline by headline, until a busy part of the Atlantic became something much larger in the public mind. Before it had a famous name, it was only ocean. Ships crossed it, planes flew over it, weather moved through it. People worked, travelled, traded, trained, and vacationed across it. There were harbours, routes, islands, schedules, cargo manifests, passengers, maps, and weather reports. Very normal things, really. But then, scattered through the years, certain disappearances began to collect around the same rough piece of sea, and once people began looking at them together, the ordinary map started to feel less ordinary. That is often how legends begin, not with a single thunderclap, but with a pattern people think they can see. One ship vanishes, then another story is remembered, then a plane disappears. Then someone notices that all these events can be placed inside the same large triangle if you are generous with the edges. And humans are very generous with edges when a mystery is involved. We like a shape. We like a boundary. We like being able to point and say, there, that is where the strange thing happens. It makes fear easier to hold. A nameless open ocean is too large. A triangle fits neatly into the imagination. Long before the phrase became famous, sailors already knew the Atlantic could be dangerous. That was not new. The sea near the Caribbean and the southeastern United States has always been a place of movement and risk. Warm water feeds storms. Reefs and shallow banks can damage ships. Currents can move with surprising force. The Gulf Stream runs like a powerful river through the ocean, carrying warm water northward and carrying debris away from where people might expect to find it. A small boat in trouble can be moved far from its last known position. A piece of wreckage can disappear into distance before a search even begins. None of this requires anything supernatural. It only requires water, weather and time. Still, once a place gains a reputation, every detail begins to feel suspicious. A delayed radio message becomes eerie. A missing lifeboat becomes a clue. A compass problem becomes part of the pattern. A lack of wreckage becomes the loudest fact of all. The Bermuda Triangle legend grew because it offered something both frightening and simple. It suggested that there might be one hidden answer behind many different accidents. One place, one force, one secret under the waves. That is much easier to remember than 100 separate explanations involving storms, fuel, maintenance, navigation, communication, and human judgment after a long day in difficult conditions. The name itself helped. Bermuda Triangle. It sounds official, clean, almost scientific. It sounds like something that might appear on a naval chart with a warning symbol beside it. But the strange thing is that the name came after the stories had already begun. The area was not declared dangerous by nature, then investigated by frightened travellers. The reputation was built by writers, reports, retellings, and the human habit of connecting dots. In the 1960s, the phrase became widely known, and once it entered books, magazines, television, and schoolyard conversations, it became difficult to remove. A good name can hold a mystery together even when the evidence beneath it is uneven. It gives the story a handle, and people do like a handle, especially when carrying something heavy. The older nickname, the Devil's Triangle, added a darker flavour. It made the place sound less like geography and more like a warning whispered between sailors. Of course, the ocean has collected these kinds of names for centuries. Sailors have always named dangers in dramatic ways, partly because danger at sea deserves respect and partly because spending weeks with nothing but water around you gives the imagination a lot of free time. Storms become beasts, currents become traps, fog becomes a wall, rocks become teeth. These are not scientific descriptions, but they tell us how people felt. The sea was not just a route, it was something you survived. The Bermuda Triangle legend fits into that older tradition. It is a modern sea story wearing the clothes of aviation and radio technology. Instead of wooden ships and lanterns, it has aircraft engines, control towers, military training flights, distress calls and search planes. But the emotional structure is ancient. Someone sets out. The weather changes, or the instruments confuse them, or no one knows exactly what happened. Then they do not return. The sea keeps the evidence. People on land try to explain it. The gap remains. The story grows. One reason the legend became so strong is that disappearance is different from disaster. A disaster with wreckage is terrible, but it gives the mind something to rest on. There is a place, a cause, a sequence. Investigators can say, this failed, then this happened, then this was the result. A disappearance is colder. It leaves people staring at a last known position, a planned route, a time on a clock, and then empty space. When there is no wreckage, the imagination has room to keep walking. It can walk for decades if nobody stops it. The ocean is very good at creating that kind of room. On land, evidence has a better chance of staying where it fell. A broken vehicle remains beside road. Tracks, marks, debris, witnesses, cameras, and buildings can help. At sea, the scene does not sit still. Waves break things apart. Saltwater damages material. Currents move debris. Storms scatter everything. Deep water hides what sinks. Even today, with satellites, sonar, GPS, aircraft, and trained search teams, finding a lost vessel or aircraft in open water can be extremely difficult. In earlier decades, it was far harder. A missing ship could become a mystery not because it had entered another dimension, but because the ocean had no obligation to preserve the evidence politely for investigators. That does not make the stories less haunting. In some ways, it makes them more so. The facts are simple enough to understand, but they do not feel comforting. A boat can sink quickly, a plane can run out of fuel, a radio can fail, a pilot can become disoriented, a storm can arrive sooner than expected, a search can cover the wrong area because the last reported position was wrong. These explanations are ordinary in the sense that they belong to the real world, but they are not small. They remind us that travel depends on many things going right at the same time. As the legend spread, certain themes repeated themselves. Compass needles were said to behave strangely. Radios were said to go silent. Skies were described as strange or empty. Ships were imagined as vanishing without a trace, as if the surface of the water had opened for a moment and then closed again. Some stories were based on real losses. Others were exaggerated. A few were attached to the triangle even when the details were uncertain, distant, or not quite inside the usual area. This is another way legends grow. They do not always lie directly. Sometimes they gather loosely. They borrow. They simplify. They leave out the dull parts, and the dull parts are often where the explanation lives. For example, bad weather is not always remembered with the same force as a final mysterious message. A maintenance issue is less memorable than a spinning compass. A known navigational problem is less exciting than a pilot saying the ocean looked wrong. Human error is uncomfortable because it is human, and because it can feel unfair to blame people who are no longer here to explain themselves. So the story drifts towards something outside human responsibility. A strange force, a cursed area, a scientific anomaly. That does not mean people are foolish for wondering. It means people are trying to make tragedy feel less random. The Bermuda Triangle also became famous during an era when aviation still carried a certain wonder. Planes had become common enough to connect the world, but not so ordinary that people had stopped seeing them as remarkable. A large aircraft crossing over open ocean still felt like an act of confidence. It still does, if you think about it for too long. You sit inside a metal tube above miles of water, eating a small packet of biscuits while pretending this is a normal Tuesday. The fact that it works almost every time is one of the great achievements of modern engineering. The fact that it does not always work is enough to keep old fears alive. Ships, too, carried a different kind of unease. A ship looks permanent. Even a medium-sized vessel seems too large to simply vanish. From the dock, it has weight, railings, engines, crew, equipment, and purpose. But scale changes at sea. A ship that looked enormous in port can become a dot between waves. A storm can make a strong hull seem fragile. A mechanical failure far from help can turn a routine passage into a serious emergency. And if no distress call gets out, the difference between safe and missing may be discovered only after someone notices the vessel did not arrive. The legend beneath the waves, then, is not only about the Bermuda Triangle. It is about our relationship with systems we trust. We trust schedules. We trust that departure leads to arrival. We trust that a route exists because many people have taken it before. Most of the time, that trust is justified. Planes land, ships dock. People complain about delays instead of disasters, which is a very good sign for civilization, even if it does make airport waiting areas slightly gloomy. The Bermuda Triangle frightens us because it interrupts that assumption. It says, what if a journey simply does not finish? What if the route is known, the machine is real, the people are trained, and still the ending is missing? There is another ingredient in the legend, and it may be the most powerful one. The Bermuda Triangle sits in waters many people associate with beauty. Blue seas, warm air, islands, beaches, coral, cruise ships, holiday brochures, and photographs where everyone appears to own at least one white linen shirt. It is not a frozen polar passage or a remote black trench at the bottom of the world. It is near places people visit for rest. That contrast makes the fear sharper. The same water that looks peaceful from a hotel balcony can become dangerous beyond the reef. The same sky that looks bright in a postcard can build thunderstorms. The same region that promises escape can become, in the legend, a place from which people do not return. This contrast helped the story spread. It gave people the uncomfortable pleasure of looking at a beautiful place and imagining something hidden inside it. Not hidden in a literal sense, necessarily, but hidden from easy understanding. A calm sea surface can reveal almost nothing about what is happening below. Depth, current, temperature, reefs, wreckage, sandbanks, marine life, and old debris can all exist under a smooth blue skin. From above, the ocean can look empty. Beneath it, the world is busy. That is not mystical. It is just difficult to see. Scientists, investigators, and skeptics have often pushed back against the legend by pointing out that the area is heavily travelled, that many cases have practical explanations, and that the number of disappearances does not appear extraordinary when compared with other busy parts of the ocean. This matters. It keeps the story from becoming careless. It reminds us that a famous mystery is not automatically a real anomaly. If millions of people cross an area safely and a small number do not, the losses may be tragic without proving that the region itself is uniquely strange. Statistics are not always comforting, but they are useful. They are the sensible friend at the sleepover who turns the light back on and explains that the scratching sound is probably a tree branch. But even that sensible friend may still glance at the window. That is where the Bermuda Triangle lives now, somewhere between explanation and atmosphere. The strongest versions of the legend are not supported by evidence in the way believers sometimes claim. At the same time, the oceanic and atmospheric risks in the region are real enough to deserve respect. The myth says there is one terrifying secret. Science says there are many ordinary hazards, and ordinary hazards can become terrifying when they overlap. A sudden storm is enough. A compass misunderstanding is enough. A strong current is enough. A tired decision at the wrong moment is enough. When several arrive together, mystery may not be far behind. The legend also survives because it is flexible. If a ship is lost, the triangle can include the sea. If a plane disappears, it can include the sky. If instruments fail, it can become magnetic. If weather changes, it can become atmospheric. If wreckage is missing, it can become oceanic. If all practical explanations sound incomplete, it can become supernatural. A flexible legend is hard to sink because it changes shape around objections. When one theory weakens, another rises. Aliens, Atlantis, sea monsters, time warps, methane bubbles, rogue waves, secret military experiments, magnetic fog. Some are imaginative, some are loosely connected to real science. Some belong more comfortably in late-night television, preferably watched with snacks and a healthy sense of caution. The scientific-sounding theories are especially interesting because they show how much people want mystery to feel respectable. A sea monster is fun, but a magnetic anomaly sounds like something that might have a diagram. A time portal is dramatic, but methane hydrate release comes with laboratory words. Rogue waves are real, powerful, and frightening, so they can be pulled into the legend even when they may not explain every famous case. This does not mean all such ideas are wrong in every situation. It means a real phenomenon can be used too broadly if it is asked to explain everything. Science usually works case by case. Legends prefer one grand answer. That is one of the reasons they argue so often. A careful view of the Bermuda Triangle must allow for uncertainty without feeding fantasy. Some events probably have explanations that are now beyond recovery because records were poor, witnesses are gone, and physical evidence was never found. Unknown does not mean impossible. It means unknown. That may sound obvious, but it is a point worth keeping close. The word unexplained can be very tempting. It sounds like a door opening onto something extraordinary. Sometimes it is only a locked filing cabinet with half the paperwork missing. Still, people are not drawn to the triangle only because they misunderstand evidence. They are drawn because the subject gathers several old fears into one place. Fear of the deep, fear of being lost, fear of machines failing, fear of weather, fear of silence after a distress call, fear that the world is less controlled than our routines suggest. These fears are not childish. They are part of being a small creature on a large planet. We can build engines, charts, satellites, and rescue systems, but we cannot make the ocean small. We can only become better at crossing it. There is also a quieter reason the legend stays alive. It gives the ocean back some of its old power in a world that often feels mapped and measured. We live with digital maps in our pockets. We can zoom from our street to the other side of the planet while waiting for toast. We can check weather radar, flight paths, shipping data, satellite images, and sea surface temperatures. This is astonishing. It is also easy to mistake information for control. The Bermuda Triangle reminds people that knowing where something is does not mean we have mastered it. A map can name a place without making it safe. A forecast can warn without preventing. A signal can fail. A search can miss. In that sense, the legend beneath the waves is not only a collection of old stories, it is a warning about confidence, not a warning to avoid the Atlantic or to fear every flight or to become suspicious of cruise brochures. More of a reminder that routine travel is still a partnership with nature. The sea has conditions, the sky has conditions, technology has limits, people have limits. When those limits are respected, the world opens. When they're ignored, even familiar routes can become dangerous. As the story grew through books and television, it also became entertainment. That part is uncomfortable, because real people were lost in the incidents that built the legend. Behind every famous disappearance were families waiting for news, crews doing their jobs, pilots following orders, sailors making decisions with the information they had. The mystery industry sometimes turns them into pieces of a puzzle and forgets they were human beings. A karma telling should remember that. The point is not to decorate their losses with wild guesses. The point is to understand how fear, grief, incomplete evidence, and public imagination can turn separate tragedies into a single lasting myth. And once a myth becomes familiar, it teaches people how to hear new information. A boat goes missing elsewhere, and it is a sad report. A boat goes missing near the triangle, and the old machinery starts up immediately. Was it the same force? Did the compass fail? Was there a strange cloud? Did anyone hear a final message? The legend becomes a filter. It does not only explain events after they happen, it shapes what people notice in the first place. Details that match the story are repeated. Details that make the story less strange are often left behind, not always intentionally, but because plain facts do not travel as quickly as eerie ones. There is a lesson in that too. The Bermuda Triangle is not just a mystery about ships and planes. It is a mystery about storytelling. It shows how facts can be arranged into a pattern, how a name can make separate events feel connected, how missing evidence can become stronger in the imagination than evidence found, and how people can be both skeptical and fascinated at the same time. You can know that the strongest supernatural claims are unsupported, and still feel a small chill when you look at the map. You can understand currents, storms, and navigation errors, and still find the open Atlantic at night a little too large for comfort. That may be the honest place to stand. Not in panic, and not in dismissal. Somewhere more careful. The Bermuda Triangle is not a proven doorway to another world. It is not an official zone where physics takes a holiday and compasses throw up their tiny magnetic hands. But it is also not nothing. It is a busy, weather-prone, historically significant region of the ocean where real accidents have happened, where searches have been difficult, and where the lack of complete answers has given the public imagination decades of material. The terror is not that science has no answers. The terror is that science has many answers, and some of them are still dangerous. By the time the name became famous, the legend already had what it needed. It had a place people could picture. It had unexplained losses. It had enough real geography to feel grounded, and enough uncertainty to feel open. It had the glamour of tropical waters and the dread of open sea. It had aircraft, ships, storms, compasses, radios, and missing wreckage. Most of all, it had silence. The silence after a call fails. The silence after a vessel does not arrive. The silence after search planes return without finding what they were sent to find. And that silence leads naturally to the stories that made the Triangle famous. The cases people return to again and again, not because they all prove the same thing, but because each one shows a different way a journey can vanish from certainty into doubt. Some began as routine assignments, some involved trained crews, some were later wrapped in exaggeration. Some still leave questions behind. To understand why the Bermuda Triangle became such a powerful legend, we have to move from the broad outline into the individual disappearances, where the map becomes a timetable. The timetable becomes a search, and the search becomes another unanswered line in the long record of the sea. There are some stories that begin loudly, with explosions, alarms, witnesses, fire and wreckage. And then there are the stories of the Bermuda Triangle, which often begin in a much quieter way. A ship leaves port. A plane lifts from a runway. A crew checks instruments, follows a route, makes ordinary decisions, and expects an ordinary arrival. Somewhere along the way, the ordinary thread breaks, not always dramatically, not always with a final shout over the radio. Sometimes there is only a routine message, a position report, a weather note, or nothing at all. Then the clock keeps moving, the destination waits, and the people expected there begin to realise that something is wrong. That is the part that gives these cases their lasting weight. Not only the loss itself, though that is serious enough, but the silence after it. A silence that begins as a delay, then becomes concern, then becomes a search, then becomes a question that may remain open for years. The Bermuda Triangle legend was built from many pieces, but its strongest pieces are these: ships that should have arrived and did not, aircraft that were heard from and then were not, searches that covered water and sky and came back with too little. It is one thing to lose something small, a key, a receipt, the lid to a container that absolutely had a lid 5 minutes ago. It is another thing entirely for a vessel of steel or a group of military aircraft to enter the record as missing. One of the oldest and most important stories connected to the legend is the disappearance of USS Cyclops. She was not a little fishing boat or a private yacht with a hopeful engine, and a captain who had perhaps trusted the weather forecast a bit too warmly. Cyclops was a large US Navy collier, built to carry coal and later used to transport cargo. In March 1918, during the First World War, she disappeared while returning from Brazil, and she took more than 300 people with her. The US Naval History and Heritage Command notes that numerous ships searched for her, but she was never found. No wreckage, no clear distress call, no final explanation that could be placed neatly into a file and closed with a sigh of relief. It is difficult to overstate how strange that must have felt at the time. A ship that large does not feel vanishable when you're standing beside it. It has height, weight, engines, compartments, crew, cargo, noise, smell, routine, and authority. But size is a very local illusion. A ship may look huge in harbour and become very small once weather, distance, and water are allowed to participate. Cyclops was carrying manganese ore, a heavy cargo, and later analysis from the Navy has suggested that a combination of design characteristics and cargo may be among the most likely explanations for her loss. That is not as dramatic as a sea monster wrapping one thoughtful tentacle around the hull, but it is more useful and perhaps more unsettling. A ship can fail not because one impossible thing happens, but because several possible things happen together at the wrong time. The mystery of Cyclops also shows one of the great difficulties in old disappearances. The farther back we go, the less complete the record becomes. Weather data may be limited, communication may have been delayed or missing, maintenance details may be incomplete, witnesses are long gone, the ocean floor is wide, uneven, and not particularly interested in helping historians. If a ship went down quickly in deep water, the evidence might be beyond practical recovery for decades, or forever. That does not make the event supernatural. It makes it difficult. And difficulty, when mixed with loss, can feel very much like mystery. Cyclops became part of the Triangle legend later, after writers began gathering old disappearances into a single pattern. At the time, it was a naval tragedy and an unsolved wartime disappearance. Later, it became one of the stones in the foundation of the Bermuda Triangle story. This happens often with legends. They reach backward. Once the name exists, older events are pulled toward it, like bits of metal toward a magnet. The event did not need to know it was inside a legend when it happened. The legend arrived afterward, carrying a label and a long memory. Then there is Flight 19, perhaps the most famous case of all. If the Bermuda Triangle had a central scene in the public imagination, this would probably be it. 5 US Navy TBM Avenger torpedo bombers taking off from Naval Air Station Fort Lauderdale on December the 5th, 1945, for what was supposed to be a routine overwater navigation training flight. The war had ended only months earlier. The pilots and crew were not characters in a ghost story. They were military aviators doing a training exercise over familiar training areas, using aircraft designed for serious work. According to the Naval History and Heritage Command, the 5 aircraft of Flight 19 were lost during that training flight, and a PBM Mariner aircraft sent out to search for them was also lost. The phrase routine training flight does a lot of quiet work here. It is precisely because the mission was routine that the story became so disturbing. Dangerous operations carry danger openly. People expect risk in combat, in storms, in experimental flights, in damaged machines. But routine has a way of calming everyone down. Routine says, this has been done before. Routine says, we know the steps. Routine says, we will be home later. When routine becomes disappearance, the mind notices. The radio communications from Flight 19 have been retold so many times that they have almost become theatre. In the simpler and spookier versions, compasses fail, the pilots become confused, the sea looks strange, and the formation drifts into the unknown. The fuller picture is more complex and less theatrical, though still deeply troubling. The flight appears to have become uncertain about its position. Navigation over open water can be unforgiving, especially before modern satellite systems. If a pilot misidentifies islands, a coastline, or direction, each correction made from the wrong assumption can carry the aircraft farther from safety. It is the kind of mistake that can grow quietly. Not like a door slamming, more like a small leak behind a wall. Weather and fading daylight added pressure. Fuel is patient but not generous. It burns at its own rate, regardless of confusion, arguments, hope, or the desire to get home. Once aircraft over water are lost and fuel becomes limited, the situation becomes very serious. A pilot can remain calm, trained, and brave, and still be trapped by arithmetic. Distance, direction, fuel, daylight, sea conditions. These are not dramatic villains. They are numbers, and numbers can be very cold company. The loss of the search aircraft makes the story even darker. A PBM Mariner was sent out to look for Flight 19 and disappeared as well. Mariners had a known reputation for fuel vapor problems, and one likely explanation is that the aircraft exploded, but the timing of its loss attached it permanently to the mystery of Flight 19. This is one of those details that shows how legends gain strength. If only the training flight had been lost, the story would already be haunting. But when the rescue aircraft vanished too, the event seemed to double itself. It gave the legend a second silence, and 2 silences close together are very hard for the imagination to leave alone. Still, Flight 19 is not frightening, because it proves a paranormal force. It is frightening because it shows how quickly confusion can become fatal when people are suspended between sea and sky. A road traveller who is lost can stop, ask for help, read signs, or wait. A pilot over water cannot stop and think for an hour. The aircraft keeps moving, the fuel keeps dropping, the sun keeps lowering. The ocean below may be too rough for survival, even if a controlled ditching is possible. Every minute matters, and every wrong assumption becomes expensive. A few years later, another kind of disappearance entered the growing mythology. In December 1948, a Douglas DC-3 aircraft, registered NC-16002, vanished during a flight from San Juan, Puerto Rico to Miami. It carried 29 passengers and 3 crew members. The aircraft had reported near the end of its route, and then it was gone. The wreckage was not found. The official investigation could not determine a probable cause because too much evidence was missing. Later summaries of the case note problems before departure, involving the aircraft's electrical system and batteries, and uncertainty over whether important communications about wind changes were received. This case does not need strange lights or impossible clouds to be unsettling. In fact, the ordinary details may be worse. Batteries, radio communication, wind shift, position reporting, fuel. These are practical things, the sorts of things that belong in checklists and reports. But when practical things line up badly, they can create an outcome that later looks almost unreal. A flight near its destination should feel safe. Miami was not some unknown island on the edge of a blank map. It was a major destination, with lights, runways, and people waiting. But being near a destination is not the same as being there. A small navigational error near the end of a long flight, especially over water and at night, can be unforgiving. There is a particular sadness in flights that vanish close to arrival. They carry a different emotional weight from journeys lost in the middle of nowhere. Everyone on board may have been thinking in ordinary arrival thoughts: collect your things, stretch your legs, find transport, go home, sleep. Maybe complain about the flight later, because humans do enjoy surviving minor inconvenience and then giving it a detailed review. Then something happens, or several somethings happen, and arrival never becomes landing. The gap between almost home and never found is very small on a map and very large in the mind. The Star Tiger and Star Ariel disappearances added still more unease to the skies around the Triangle legend. These were British South American Airways aircraft, and they vanished in 1948 and 1949. Star Tiger disappeared during a flight from the Azores toward Bermuda. Star Ariel disappeared almost a year later after leaving Bermuda for Jamaica. Britannica notes that Star Ariel made a routine communication not long after departure, and then disappeared completely. These cases have that same quiet structure: a known flight, a normal message, and then absence. What made these disappearances so disturbing was not only that aircraft were lost, but that modern aircraft seemed to challenge the old idea of the sea as the main keeper of secrets. For centuries, ships had vanished because the ocean was large and communication was poor. Aviation was supposed to rise above that old uncertainty, at least in feeling. Planes were fast, they had radios, they crossed distances that once took days or weeks. They belonged to the new age. And yet, over open water, an aircraft in trouble could still disappear into the same old problem. No witnesses, no easy wreckage recovery, no clear final scene. That is one of the quiet truths behind the Bermuda Triangle. The sky over the sea can be just as lonely as the sea itself. From the ground, we often think of aircraft as constantly connected, but for much of aviation history, communication over ocean routes was limited, imperfect, and dependent on equipment, range, weather, and procedure. A missed transmission might mean nothing, then it might mean something, then it might become the last known point in a disappearance. The line between ordinary silence and dangerous silence is not always clear at first. Ships continue to add to the legend as well. The Marine Sulphur Queen, a converted tanker carrying molten sulphur, disappeared in 1963 with 39 men aboard. The Coast Guard report states that the vessel was last heard from at 1:25 a.m. Eastern Standard Time on February 1st, 1963, and that the ship and crew disappeared. The report also drew attention to the vessel's conversion and condition, placing the mystery less in a magical disappearance and more in serious practical concerns about whether the ship should have been at sea in that form at all. The Marine Sulphur Queen is a good example of how the Bermuda Triangle can turn engineering failure into folklore. A ship carrying molten sulphur already sounds like something that should be handled with care, and preferably by people who are not also having a bad week. The vessel had been converted from its original use, and later investigation raised concerns about structural and safety issues. Those details matter. They do not make the loss less tragic, and they do not remove every question, but they shift the feeling of the case. The mystery becomes not, what impossible force took this ship? It becomes, what risks were built into the ship before it ever left port? That question is less glamorous but far more important. Legends tend to focus on the final moment because that is where the darkness gathers. Science and investigation often look earlier. They ask about design, maintenance, loading, weather, training, inspection, communication and decision-making. They ask not only what happened at the moment of loss, but what conditions made loss more likely. This is one reason scientific explanations can feel less satisfying than supernatural ones. They spread responsibility across many ordinary details. A ghost is easier to understand than a maintenance history. The sea, however, does not care which explanation is more satisfying. It works with conditions. If a vessel is weak, overloaded, poorly converted, caught in rough seas or carrying dangerous cargo, the risk increases. If a plane has electrical problems, radio limitations, uncertain position, or fuel concerns, the risk increases. If weather reduces visibility or changes faster than expected, the risk increases. The Bermuda Triangle legend often presents disappearances as sudden and clean, like a magician pulling a cloth from a table. Real accidents are often messier. They develop from chains of small and medium problems that may not look fatal until the chain is complete. Another recurring theme is the missing distress call. People often ask why no one called for help. It is a fair question, but not always a mysterious one. Emergencies can unfold too quickly. A radio may fail. A crew may not understand the danger until it is too late. A pilot may be too busy trying to control the aircraft. A ship may lose power. A vessel may capsize, break apart, or sink before a message can be sent. Panic is not required. Even skilled people can run out of time, and sometimes a distress call may have been sent but not received, or received unclearly, or lost in the limits of older communication systems. The lack of wreckage is another powerful part of the legend. It feels wrong. When something large breaks, we expect pieces, we expect proof. But the ocean is not a dry floor where evidence stays put until someone sweeps it up. Floating debris can scatter. Heavy debris can sink into deep water. Currents can move objects far from the search area. The Gulf Stream, which runs near parts of the triangle, can carry material quickly away from where a vessel or aircraft may have gone down. Search teams often begin with the last known position, but if that position is wrong, old, or incomplete, the search area grows fast. A few hours of uncertainty can turn into thousands of square miles. That is not a mystery in the supernatural sense. It is geometry being unpleasant. And when searches fail, stories harden. People say, no trace was ever found, and the phrase lands heavily. Sometimes it is accurate. Sometimes small traces were found but did not answer enough. Sometimes wreckage was discovered years later and failed to receive the same attention as the original disappearance. The first version of a mystery often becomes the version people remember. Corrections arrive later, wearing sensible shoes and carrying documents, and they rarely get the same applause. This does not mean the famous disappearances should be dismissed. They deserve attention precisely because they reveal how hard transportation over open water can be. Flight 19 shows the danger of navigational uncertainty and time pressure. Cyclops shows how a large vessel can be lost when evidence is swallowed by distance and depth. The DC-3 case shows how electrical and communication issues can matter, especially near the end of a long overwater flight. Marine Sulphur Queen shows how ship design and condition can turn a voyage into a risk before the weather even has an opinion. Each case is different. The legend tries to make them the same. That is where we have to be careful. NOAA's position is worth keeping beside us as we move through these stories. There is no evidence that mysterious disappearances happen more frequently in the Bermuda Triangle than in other large, heavily travelled areas of ocean. That statement does not erase the losses. It places them in context. A busy ocean will produce accidents. A famous ocean will produce famous accidents. The difference matters. If a region has many ships and aircraft passing through it, the raw number of incidents may seem impressive, but numbers without traffic volume can mislead. It is a little like saying a large city has more lost umbrellas than a small village, and therefore must contain an umbrella-eating curse. Tempting, perhaps, but not our strongest work as a species. Still, even if the triangle is not statistically exceptional, the stories remain emotionally exceptional because they are told together. The human mind is a pattern-making machine. It connects names, places, dates, and details. It does not like isolated tragedies floating separately. It wants them tied with string on a board, preferably in a dimly lit room where someone has access to too many red pins. The Bermuda Triangle became famous because it gave people a pattern they could see. Ships, planes, silence, no wreckage, warm water, strange name. That pattern is simple enough to remember and flexible enough to survive. But when we slow down, the pattern changes. It becomes less like one giant secret and more like a collection of warnings. Do not underestimate weather. Do not overtrust routine. Do not ignore maintenance. Do not assume communication will work because it worked yesterday. Do not forget that navigation is a skill, not a decorative feature. Do not expect the sea to preserve your evidence. These are not glamorous lessons, but they are the kind that keep people alive. The truly frightening part of the Bermuda Triangle may be that the stories do not require the laws of physics to break. They only require people and machines to meet difficult conditions in a place where rescue is hard and evidence is harder. That is enough. A compass does not need to spin wildly for a pilot to become uncertain. A wave does not need to be legendary to damage a ship. A storm does not need to be the worst storm in history to overwhelm a crew already dealing with another problem. Most disasters do not begin as disasters. They begin as manageable issues that gather company. There is also a difference between terror and panic. Panic says something impossible is out there. Terror, the quieter and more durable kind, says something possible is out there, and it has happened before. The Bermuda Triangle still frightens people because the possible explanations are not comforting. Mechanical failure is possible. Human confusion is possible. Sudden weather is possible. Structural weakness is possible. Failed communication is possible. Deep water hiding wreckage is possible. None of these need a glowing portal. None of them care whether the story becomes famous afterward. As we look at the disappearing ships and silent skies, it helps to remember the people inside these cases. A radio operator leaning towards static. A pilot trying to decide which direction is west when the sea below offers no helpful answer. A crew member on a ship that feels different in rough water. A family member waiting for the arrival call. The legend often turns them into evidence. They were more than that. They were workers, travellers, officers, passengers, sons, fathers, friends and strangers who expected the normal rules of departure and arrival to hold. Most of the time, those rules do hold. That is why we trust them. But the exceptions are enough to leave a mark. So the Bermuda Triangle's famous disappearances are not best understood as one locked room mystery. They are more like a long hallway of partly open doors. Behind one door may be navigation. Behind another, weather. Behind another, cargo, behind another, mechanical failure, behind another, poor communication, behind another, simple bad luck arriving at the worst possible moment with its coat already on. The legend invites us to throw all the doors open and look for one monster at the end. Science asks us to look carefully behind each door, even if the answer is less dramatic than expected. And that careful looking leads us away from the names and into the place itself. Because ships and planes do not vanish in a blank space. They move through geography. They move over currents, between islands, across shallow banks and deep channels, through weather systems and magnetic variation, under skies that can change from clear to dangerous with very little concern for human plans. To understand why so many stories gathered here, we have to stop treating the Bermuda Triangle as a symbol for a moment and begin treating it as a real part of the Atlantic, with real distances, real routes, real water, and real conditions that can make even an ordinary journey feel much less ordinary once the land has dropped out of sight. To understand why the Bermuda Triangle feels so unnerving, it helps to stop thinking of it as a single dark patch on the map and start thinking of it as a real stretch of ocean with real shape, real movement, real weather, real depth, and a slightly inconvenient habit of refusing to fit into simple explanations. The geography matters. It matters more than the name, more than the rumours, and certainly more than the dramatic maps that make the place look as though nature itself took out a pencil and drew a warning sign between Florida, Bermuda, and Puerto Rico. Nature, as far as we can tell, did not do that. Humans did. Humans saw a collection of events, drew lines around them, gave the shape a name, and then acted surprised when the name began to feel powerful. The first strange thing about the Bermuda Triangle is that it is not an official place in the way a country, a sea, or a national park is an official place. You cannot sail across a clearly marked border and expect a sign floating beside you saying, "Welcome to the Bermuda Triangle. Please keep your hands and feet inside the mystery at all times." Its borders have shifted depending on who is telling the story. Some versions draw the triangle from Miami to Bermuda to Puerto Rico. Others stretch it farther, taking in more of the Atlantic, more of the Caribbean, and more opportunities for accidents to be counted inside it. The larger the triangle becomes, the more incidents it can collect, which is very useful if you're building a legend and less useful if you're trying to be precise. That lack of fixed borders is not a small detail. It is one of the reasons the legend has been so hard to pin down. When the place itself is flexible, the story can be flexible too. If a vessel disappears near the expected area, the triangle can seem to reach for it. If a plane is lost along a route that passes somewhere near the region, the story can include that as well. This does not mean every writer who ever discussed the Bermuda Triangle was being dishonest. It means that once a place becomes famous for mystery, people begin to treat geography with a softness they would never accept from a parking ticket. The map becomes less like a measurement and more like a mood. Still, even if the edges are uncertain, the general region is very real. It lies in a part of the western North Atlantic where the coast of Florida, the islands of the Bahamas, Bermuda, Puerto Rico, and the wider Caribbean create a complicated meeting ground for sea routes and air routes. This is not a remote dead zone at the far end of the world. It is close to major ports, airports, holiday destinations, military training areas, and commercial routes. It is crossed by cargo ships, cruise ships, fishing boats, private vessels, military aircraft, commercial planes, and people who simply want to get from one warm place to another without becoming part of a documentary later. That heavy traffic matters because danger often appears where movement is common. If thousands upon thousands of journeys pass through a region, some will go wrong. The Bermuda Triangle's reputation can make those incidents feel like proof of a special danger, but a busy region will naturally produce more reports than a quiet one. A road with 1 million cars a year will have more accidents than a country lane with 3 tractors and a sheep who seems to know what he is doing. That does not automatically make the busy road cursed. It makes it busy. The same principle applies at sea and in the sky. though the consequences can be much more serious and the wreckage is much harder to find. The geography of the region also changes very quickly from one kind of water to another. Around the Bahamas, for example, you can find shallow banks where the sea is pale turquoise, bright, clear, and beautiful enough to make travel brochures look almost restrained for once. The Great Bahama Bank is a broad area of shallow water, and in places the edges of these banks drop away into much deeper water. Nearby, features like the tongue of the ocean create a stark contrast between shallow bank water and deep blue basin. From above, this is stunning. From a navigation standpoint, especially for smaller boats, shallow banks, reefs, channels, cuts, sandbars, and sudden depth changes require attention. The ocean floor is not a smooth bathtub. It has shelves, ledges, holes, slopes, and underwater geography that can matter very much if you're moving across it in weather, darkness, or poor visibility. This is one of the quiet tricks of tropical water. It can look friendly. Clear water can give a sense of safety because you can see colour, light, and sometimes the bottom. But clear does not mean simple. Shallow does not mean harmless. A reef is not softer because the water above it is pretty. A sandbar does not move out of the way because your boat has plans. Channels can funnel currents. Tide can change how water behaves in narrow passages. Wind against current can make waves steeper and more unpleasant. And if a vessel is underpowered, poorly handled, damaged, or caught at the wrong angle, even a beautiful day can begin to develop sharp little teeth. Beyond the banks, the water becomes deep. Very deep in some places. This matters for the mystery because deep water hides evidence. If a plane goes down over land, investigators may find wreckage, burn marks, broken trees, impact scars, or debris spread across a field. If a plane or ship goes down in deep ocean, the situation changes completely. Heavy pieces sink, floating pieces scatter, salt water damages what remains. Currents move debris away from the last known position. Search teams are forced to work with estimates, drift models, weather, reports, and sometimes very little certainty. If the last position was wrong, or if no one knew exactly when the trouble began, the search area can grow from difficult to enormous with depressing speed. This is where the geography becomes part of the fear. The Bermuda Triangle is not terrifying because it is a hole in the world. It is terrifying because it contains a lot of ordinary ways to lose track of things. A vessel can leave a known harbour, pass beyond easy sight, and enter a space where location depends on instruments, skill, communication, and conditions. A plane can fly over water that offers very few visual references. Before satellite navigation became common, position could depend on radio navigation, compass headings, dead reckoning, celestial navigation, landmarks when available, and human interpretation. Over open water, a small error can become a large one. There are no street corners in the Atlantic, no helpful road signs, no sleepy petrol station attendant telling you that Bermuda is definitely not that way. The Gulf Stream adds another layer. It is a powerful ocean current that moves warm water from the Gulf region through the Straits of Florida and up along the eastern coast of North America, before continuing into the North Atlantic. Near the surface, it can move quickly enough to carry floating debris far from where an accident may have happened. That matters in search operations because the place where something goes wrong is not always the place where pieces will be found. A life jacket, cushion, oil slick, or fragment of wood may not stay politely above the sinking site, waving at rescuers like a well-trained clue. It may travel, it may spread, it may break apart, and if the sea is rough, the evidence may become even harder to recognise. This also affects how people remember disappearances. When wreckage is not found, the absence feels meaningful. It feels like the ocean has done something impossible. But in a moving current, absence can simply mean that the search area was wrong, too small, too late, or too difficult. That is not comforting, but it is practical. The sea can hide things without being mysterious. It can hide them by being large, deep, moving, and dark below the surface. That is already enough. Weather is tied closely to geography too. Warm ocean water can feed storms. The region sits in an area affected by tropical weather systems during hurricane season, and even outside major hurricanes, thunderstorms, squalls, and sudden local changes can create danger. A sky that looked manageable at departure may not remain that way. Pilots and sailors know this, of course. But knowing a thing and escaping it are not always the same. Weather is not a decoration in a disappearance story. It can be the main character, even when the legend would prefer a more exotic guest. Small craft are especially vulnerable. A large cargo ship and a small private boat do not experience the same sea. What's uncomfortable for one may be life-threatening for another. A sudden squall, engine trouble, a navigation error, or a delayed decision can place a small vessel in real danger. The Bermuda Triangle region has long attracted private boaters because it includes desirable islands, warm waters, fishing grounds, and routes that look manageable on a map. But maps flatten distance. They make water look still. A line drawn between 2 points does not show fatigue, fuel concerns, mechanical trouble, cross seas, a failing radio, or the simple discomfort of realizing that the weather has changed and land is not where you would like it to be. That is one of the reasons the Triangle's geography has such psychological force. It is close enough to feel familiar, but open enough to become dangerous. Florida is not remote. The Bahamas are not remote in the public imagination. Bermuda is famous, visited, photographed, and very much part of the modern world. Puerto Rico is a major island with cities, airports, and history. These places are not fantasy locations. They are real, reachable, and connected. Yet between them lies open water large enough to make human confidence feel temporary. The mind does not expect mystery beside vacation brochures, and that contrast makes the story sharper. There is also the problem of visual sameness. On land, even a lost traveller has references. Hills, roads, buildings, signs, rivers, lights, fields, and towns all help the brain understand position. At sea, especially beyond sight of land, the horizon repeats itself. Water in every direction can make distance difficult to judge. In the air, cloud cover or haze can make the surface below look featureless. Before modern systems, this placed more weight on instruments and calculations. If those instruments were misunderstood, malfunctioning, or contradicted by what someone believed they saw, confusion could build. Not because the place was enchanted, but because the environment was poor at giving helpful feedback. The Bermuda Triangle sits in a region where islands complicate this even further. The Bahamas, for instance, are not one simple landmass. They are an archipelago of islands, cays, channels, banks, reefs, and passages. From above or at sea, especially in poor weather or fading light, identifying the correct island or bank could be difficult. If a pilot or sailor mistook one feature for another, the resulting navigation decisions could be wrong while still feeling reasonable at the time. This is the dangerous kind of error. The one that does not feel like error while it is happening. It feels like solving the problem. Only later does the path reveal itself as a mistake. The geography also creates search problems because the possible environments are so varied. A missing vessel might have struck a reef in shallow water, drifted into a current, sunk in deep water, burned, capsized, or been broken apart by weather. A missing aircraft might have gone down in shallow water where wreckage could be scattered, or in deep ocean where recovery would be extremely difficult. The same general region contains conditions that require different search methods. Shallow banks may be visually searchable under good conditions, but sand, coral, and clear water can also create confusing patterns. Deep basins require sonar and time. Strong currents require drift calculations. Weather can delay or disrupt everything. The map may be a triangle, but the search problem is not neat at all. Another part of the geography of fear is distance. On a classroom map, Florida, Bermuda and Puerto Rico can look close enough to sit comfortably in one glance. In reality, these are large ocean distances. Bermuda is isolated far out in the Atlantic compared with the island chains of the Caribbean. Routes between these points cross wide stretches where immediate help may not be available. Distance changes the meaning of trouble. An engine problem near a dock is an inconvenience and possibly an expensive afternoon. An engine problem far offshore is a different story. A wrong heading near a coastline can be corrected when land appears. A wrong heading over open sea may use fuel before the mistake becomes obvious. This distance also affects communication. Today, technology is far better than it was during many of the famous Bermuda Triangle cases. GPS, satellite communication, emergency beacons, improved radar, better forecasting, and stronger search and rescue systems have changed the risk picture. But the legend was built largely from incidents that occurred when navigation and communication were more limited. A missed report, a weak radio signal, equipment trouble, or a misunderstanding could matter a great deal. It is easy to look backward from the age of smartphones and assume every missing person should have left a trail. Earlier, travellers did not move through that kind of connected world. They moved through gaps, and even now, the ocean can create gaps. Devices fail, signals may be blocked or lost, batteries die, people make mistakes, weather interferes. A location beacon helps only if it works and if someone receives and responds to it. Modern tools reduce risk, but they do not delete geography. They do not make deep water shallow. They do not stop currents. They do not calm storms. They do not turn a poor decision into a good one. The Bermuda Triangle remains useful as a reminder that technology improves our odds, not our importance to nature. The triangle's location also places it near routes shaped by history. Ships have moved through these waters for centuries because the Caribbean, North America, and the Atlantic world are connected by trade, colonization, war, migration, tourism, and commerce. Sea lanes are not random. They follow useful paths, ports, currents, winds, and economic need. Aircraft routes developed for similar reasons, linking islands, mainland cities, military bases, and long-distance travel. Where roots gather, stories gather. A region crossed by many people over many years becomes a collector of human experience, and not all experience is safe. There is a strange unfairness in how geography is remembered. A safe crossing leaves almost no story. Thousands of ships and planes pass through the region without incident, and no one writes a famous book called Everything Went Quite Well Between Miami and San Juan. It would be accurate, perhaps even reassuring, but it would not sell many copies. Accidents, on the other hand, leave marks. They are repeated, renamed, and linked together. The geography becomes known not by its normal outcomes, but by its exceptions. That is understandable. Humans are built to remember danger. Still, it can distort the map. A place crossed safely every day can become famous for the few journeys that did not end as planned. The idea of the Bermuda Triangle also benefits from its simple shape. A triangle feels deliberate. It has points, sides, and an inside. It is easy to draw and easy to remember. If the same incidents had been scattered across an irregular blob called the generally unsettling Western Atlantic Patch, the legend might not have travelled quite so well. A triangle feels designed, even when it is not. It gives the illusion that the place has structure and intention. People are more likely to believe in a mystery that fits inside a clean geometric form. It looks tidy, and tidy mysteries are easier to discuss after dinner, but the actual geography is not tidy. It includes shallow turquoise banks, deep blue basins, island chains, open ocean, fast currents, shipping routes, air corridors, reefs, storms, and long distances. It includes places full of tourists and places where, at night, the nearest light may be far behind the horizon. It includes calm days where the water looks like glass, and dangerous days where a small craft would be very foolish to test its luck. It includes modern navigation and old stories, scientific skepticism and human fear. The triangle is not one environment. It is many environments wearing one famous name. This is why the geography can be frightening without being supernatural. It does not need a single hidden force. It only needs complexity. Complexity is often the real source of danger. When currents, weather, navigation, vessel condition, communication, and human decision-making all interact, the outcome can change quickly. A storm alone may be survivable. A mechanical issue alone may be survivable. A navigation error alone may be survivable. But combine them and the margin narrows. The Bermuda Triangle legend often looks for one cause beneath the water. Geography suggests something more practical and more serious. Many causes sharing the same space. That may be why scientists remain interested, even if they are not frightened in the way old television specials would like them to be. The region is a natural meeting place for questions about oceanography, meteorology, navigation, search and rescue, risk perception, and human storytelling. It shows how a place can be ordinary in statistical terms and still extraordinary in cultural memory. It shows how a famous map can shape what people believe about accidents. It shows how natural hazards become more powerful when evidence is difficult to recover. And it shows how the ocean, even in a mapped and monitored age, still resists being made simple. If there is fear in the geography, it is not the fear of a monster under the surface. It is the fear of scale. The water is larger than the vessel. The weather is larger than the plane. The current is stronger than the floating debris. The search area is larger than the last known point. The map is cleaner than the world it represents. And somewhere between those facts, the Bermuda Triangle found its reputation. This does not make every disappearance mysterious in the same way. It does not prove that the region has a special appetite for ships and planes. It does not mean pilots whisper nervously to one another every time they cross it, or that sailors pass through with one hand on the wheel and the other writing a farewell letter just in case. Most crossings are normal. Most journeys end exactly as expected. People arrive, collect their bags, tie up their boats, check into hotels, eat dinner, and never think about the triangle at all. Ordinary success is the main event. The legend survives on the rare failures. Still, when we place those failures inside the region's actual geography, the stories become easier to understand and harder to laugh away. Not because the wildest claims become true, but because the real world becomes clearly dangerous enough. The warm water, the shallow banks, the deep channels, the fast current, the changing weather, the long routes, the heavy traffic, the uncertain borders, and the difficulty of search all help explain why this area became such fertile ground for fear. The Bermuda Triangle is not terrifying because it is nowhere. It is terrifying because it is somewhere very real, and real places have real ways of humbling us. And once we understand the map, the next question becomes more specific. If geography creates the stage, what are the forces acting on it? One of the oldest claims attached to the triangle is that compasses behave strangely there, that navigation itself becomes unreliable, that the simple act of knowing which way you're going can begin to break down. Some of those claims have been exaggerated, some misunderstood, and some tied to real concepts in Earth's magnetic field. So from the shape of the water, the islands, the currents and the distances, we move toward the needle, the dial, and the uneasy idea that a traveller can be moving with confidence while their sense of direction is quietly slipping away. For a mystery that spends so much time in the water, the Bermuda Triangle has always had one foot planted firmly on the compass needle. Long before people argued about methane bubbles, rogue waves, lost civilizations, or visitors from the stars with unusually poor filing habits, there was a simpler and more practical fear. What if the instrument telling you where to go was wrong? Not slightly wrong in a harmless way, like a bathroom scale after a holiday meal, but wrong enough to send a ship or plane away from safety while everyone on board still believed they were heading home. There is something especially unsettling about compass confusion, because a compass feels honest. It is small, quiet, and wonderfully serious. It does not blink, boast, or ask for applause. A needle turns, settles, and points. That is all. It seems like one of the most basic agreements between humans and the planet. We stand here. North is that way. The rest can be worked out from there. So when stories of the Bermuda Triangle began to include spinning needles, strange readings, and pilots unsure of direction, the fear felt deeper than ordinary mechanical failure. It suggested that the world itself might be refusing to give straight answers. Of course, the first thing to understand is that compasses are not magical truth machines. They are useful instruments that respond to Earth's magnetic field, and Earth's magnetic field is not the same thing as the neat geographic grid printed on a map. Geographic north, or true north, points toward the North Pole on Earth's axis of rotation. Magnetic north points toward the moving region in the Arctic where Earth's magnetic field guides a compass needle. Those two directions are usually not identical. The difference between them is called magnetic declination, or magnetic variation, and navigators have had to account for it for centuries. NOAA's National Centres for Environmental Information defines magnetic declination as the angle between magnetic north and true north, and it changes with both place and time. That sounds simple when said slowly in a warm room with no one depending on you to find an island in the dark. But at sea or in the air, declination matters. If your compass points a few degrees away from true north, and you do not correct for it properly, that small angle can become a large error over distance. Imagine walking across a field while aiming only a few degrees off your intended path. You might still arrive close enough to pretend it was deliberate. Now imagine flying or sailing for many miles over open ocean, where there are no roads, no trees, no buildings, and no helpful sign saying, "You are now confidently wrong." A small navigational error can stretch quietly until it becomes a serious problem. This is where the Bermuda Triangle legend found a useful ingredient. The region has sometimes been associated with the agonic line, the line on Earth where magnetic north and true north line up, meaning magnetic declination is zero. In such places, a compass points toward true north without needing correction. That sounds helpful, and it is, if you know what you're doing. But if a navigator expects to apply a correction and should not, or fails to apply a correction when one is needed elsewhere, confusion can result. NOAA's Bermuda Triangle page mentions that there is some evidence for the idea that in the region, a magnetic compass sometimes points toward true north rather than magnetic north. That sentence has travelled very far in the popular imagination. In careful language, it means navigation in the area can involve normal magnetic variation that must be understood. In dramatic language, it becomes, compasses go mad in the triangle, which is much more exciting, though less useful if you are trying to stay alive. A compass pointing to true north is not misbehaving. It is not possessed. It has not seen something under the waves and lost its nerve. It is simply responding to the local relationship between magnetic north and true north. The problem begins when humans misunderstand the reading, or when later storytellers turn ordinary magnetic behaviour into a sign of something impossible. This distinction is important because the Bermuda Triangle legend often turns normal, navigational complexity into a supernatural symptom. A compass does not have to spin wildly to create trouble. It only has to be read incorrectly, trusted under the wrong assumption, or combined with poor visibility, bad weather, stress, fatigue, radio trouble, or fuel concerns. Accidents rarely need one dramatic failure. They often need a small committee of practical problems, each wearing a sensible jacket and carrying a clipboard. Together, they can be far more dangerous than any single theatrical event. In the days before modern GPS, navigation over open water was a demanding skill. Sailors and pilots used compasses, charts, dead reckoning, radio navigation, celestial navigation, landmarks when available, speed estimates, wind correction, drift correction, and experience. Dead reckoning, despite sounding like a phrase invented by a pirate with a gloomy personality, simply means estimating current position based on a previous known position, course, speed, and time. It is useful, but it depends on good information. If your starting position is wrong, your heading is wrong, your speed estimate is off, wind or current is not properly accounted for, or your compass correction is misunderstood, then your estimated position begins to drift away from reality. Over land, reality may correct you. A road, river, town, railway, hill, or coastline can tell you that your mental map has wandered off. Over water, especially under cloud at night or in haze, there may be very little to correct the mistake. The sea can look the same in every direction, which is beautiful for postcards and deeply unhelpful for navigation. Pilots in earlier eras could misidentify islands or coastlines. Sailors could misread their position after current drift. A crew could believe they were west of a point when they were actually east, or think they had crossed a line they had not crossed at all. Once a wrong belief takes hold, every new decision may make sense inside that belief while carrying the journey farther from safety. This is why compass confusion became such a powerful part of the triangle story. It is not just about the instrument. It is about the terrifying possibility that a person can be wrong without feeling wrong. A needle gives a direction, a chart gives a route, a calculation gives confidence. Then clouds cover the sun, the radio signal is weak, the sea below looks unfamiliar. Fuel is decreasing, and the mind begins to look for certainty. In that situation, the difference between true north and magnetic north is not a dry technical detail. It is part of the fragile chain that connects intention to arrival. One of the most famous Bermuda Triangle stories, Flight 19, is often told through this lens. The popular version suggests that the flight's compasses failed and the pilots became lost over the Atlantic. The fuller historical account is more complicated, but navigational confusion was clearly central to the event. 5 US Navy TBM Avenger aircraft took off from Naval Air Station Fort Lauderdale on December 5th, 1945 for an overwater training flight, and the flight was eventually lost. A search aircraft sent afterward was also lost. The details have been debated, retold, simplified, and dramatized, but the emotional force remains the same. Trained airmen, familiar procedures, open water, uncertain position, and the clock of fuel running down. The Bermuda Triangle did not need to invent navigational fear. It only made that fear famous. Every navigator knows that direction is not just direction, it is trust. A compass heading must be matched with correction, speed, drift, weather, and position. If any of those pieces become uncertain, the heading alone may not save you. Following a compass faithfully can still take you to the wrong place if the plan behind it is flawed. That is a rather uncomfortable lesson, because it means confidence is not the same as accuracy. A person can be calm, disciplined, and mistaken. Magnetic declination also changes over time, which adds another layer. Earth's magnetic field is generated by motion in the planet's outer core, and it shifts. Magnetic north is not fixed in place like a pin in a map. Because the field changes, magnetic models are updated for navigation. NOAA's World Magnetic Model is used for navigation and heading systems, and the current WMM 2025 version was released on December 17th, 2024, to remain valid until late 2029. This is not strange in a Bermuda Triangle sense. It is normal geophysics. The planet is not a rigid compass card. It is a rotating, layered, active world with a magnetic field that slowly changes, like a very serious geological cat deciding to sit in a different spot every few years. For most everyday users, this is not alarming. Your phone compass, aircraft systems, marine navigation equipment, charts and models account for magnetic information in ways that are far better than older tools. but the changing magnetic field is a reminder that navigation has always required updates, correction, and attention. If you use old charts, ignore declination, misunderstand magnetic headings, or assume the compass points exactly where the map points, trouble can follow. Again, no curse is required. A few degrees and enough distance can do the work. There is another word that sometimes enters the discussion: deviation. Declination is the difference between magnetic north and true north, caused by Earth's magnetic field. Deviation is the error introduced by the vessel or aircraft itself. Metal structures, electrical systems, engines, cargo, tools, and nearby objects can affect a compass. On ships, magnetic compasses are adjusted and corrected because the ship's own magnetic influence can pull the needle away from what it would otherwise show. A compass beside the wrong metal object can become less trustworthy. This is why navigators treat compass use as a serious procedure, not as a decorative spinning toy. It is also why anyone who has ever tried to use a phone compass next to keys, a laptop, or a car door may have seen it behave with the confidence of a pigeon in a shopping mall. Now place these ideas inside the Bermuda Triangle's geography. You have long overwater routes. You have islands that can be mistaken under poor conditions. You have weather that can reduce visibility. You have currents that can move ships or floating evidence. You have routes that were historically flown and sailed before modern satellite tools were available. Add magnetic declination, possible compass deviation, human interpretation, and time pressure, and the mystery begins to look less like one grand anomaly, and more like a place where ordinary navigation problems can become serious. That is not as neat as saying the triangle bends compasses, but it is far more believable. The legend, however, prefers a needle that spins. A spinning compass is a perfect image. It is simple, visual, and frightening. It tells the audience that even direction has collapsed. In films and television, a spinning compass is shorthand for entering the unknown. It means the normal rules have stopped. It is no wonder the image became attached to the Bermuda Triangle. It gives the invisible fear a visible sign. But in real navigation, the most dangerous compass problem may not be dramatic at all. It may be steady, readable, and wrong in a way that no one recognizes soon enough. That kind of mistake is harder to dramatize but easier to believe. A pilot thinks he is north of the Bahamas when he is actually somewhere else. A sailor underestimates current. A heading is followed without the right correction. A radio beacon is misunderstood. A landmark is misidentified. A course is adjusted based on an incorrect assumption. Each step feels rational. The route becomes a trap not because the compass is possessed, but because the mental picture of the journey no longer matches the real one. This is especially important in aircraft because aircraft cannot simply pause. A boat can sometimes stop engines, heave to, drop anchor in shallow water, or wait, though not always safely. A plane must keep flying. It has fuel limits, weather limits, daylight concerns, and mechanical limits. If a pilot is uncertain over open water, every minute spent deciding is also a minute spent moving and burning fuel. A wrong turn may not reveal itself until the range to safety has become smaller than the distance remaining. That is a very serious form of arithmetic, and arithmetic is famously unsympathetic to hope. Compasses also sit inside a wider system of navigation. Even if the compass is correct, it does not solve every problem. Wind can push an aircraft off course. Currents can affect vessels. A heading tells you the direction the nose or bow is pointed, not always the exact path over ground or water. This is an easy distinction to miss if you have never had to navigate in moving air or water. You can point one way and travel slightly another because the medium around you is moving too. A boat crossing a current must account for drift. An aircraft flying in wind must correct its heading to maintain track. Without that correction, the route can slide sideways. It is rather like trying to walk in a straight line across a moving walkway while pretending the walkway has no opinions. In the triangle region, The Gulf Stream makes this especially relevant for ships and debris, and winds matter for aircraft. A navigator who fails to account properly for drift may end up somewhere unexpected. The error might not be obvious until the expected landmark does not appear, the expected radio signal is weak, or fuel calculations begin to look uncomfortable. This is the practical heart of many disappearance scenarios. Not one huge, impossible event, but a slow mismatch between expectation and reality. Modern navigation has reduced many of these risks. GPS can provide accurate position. Electronic charts can display location in real time. Aircraft and ships have multiple systems. Emergency beacons can transmit distress locations. Weather forecasting is better. Communication is better. Magnetic models are updated. But the old Bermuda Triangle stories were shaped by earlier tools and earlier limitations. A disappearance from 1918, 1945, 1948, or 1963 should not be judged as if everyone involved had today's equipment. They did not. They travelled through a world with larger gaps, and those gaps became part of the mystery. Even now, people can overtrust technology. This is one of the more modern versions of compass confusion. A person may assume that because a device shows a line, the route is safe, but a navigation display is not judgment. It can tell you where you are, but not always whether the weather ahead is wise, whether your vessel is fit, whether your fuel margin is sufficient, whether you understand the route, or whether you're becoming too tired to make good decisions. The old compass needle and the modern screen both require a human being to understand what they mean. Tools are very helpful. They are not adult supervision. The Bermuda Triangle legend also reveals how technical language can become mystery language. Magnetic variation, declination, agonic line, compass deviation, geomagnetic field. These are real terms, and because they are real, they can be used carefully. But they can also be used loosely to make a story sound scientific without actually explaining it. A storyteller can say, magnetic anomaly, and the listener may feel that something profound has been identified, even if no specific anomaly has been measured or tied to the event. This is not science. It is atmosphere wearing a lab coat. That does not mean magnetic effects are irrelevant. It means they must be specific. What was the declination at that location and date? Was the compass adjusted? Was the navigator trained? Were charts current? Was there evidence of instrument failure? Were there other navigation aids? What was the weather? What were the winds or currents? What was the last known position? Without those details, saying magnetic mystery is a little like saying engine trouble after hearing a noise in the kitchen. It might be true if there is an engine in the kitchen, but we should probably check before becoming too confident. The reason scientists tend to be cautious about the magnetic claims is that a broad magnetic explanation for the Bermuda Triangle does not hold up as a single cause. NOAA's page states that no official maps define the Bermuda Triangle, and that the US Navy and US Coast Guard do not accept supernatural explanations for disasters there. Their experience points instead to the combined forces of nature and human fallibility. That phrase, nature and human fallibility, is not as flashy as the compass went mad, but it fits the evidence more often. It allows for bad weather, difficult seas, errors, mechanical problems, poor decisions, and incomplete evidence. It is less cinematic, but it is sturdier. Still, there is something emotionally powerful about the compass idea. Direction is one of the most basic forms of safety. A child learns very early that being lost is frightening. Adults cover that fear with maps, apps, signs, schedules, and confidence. But the older fear remains. To be lost over water is to have that childhood fear enlarged by geography. There are no familiar streets, no front doors, no neighbours, no shop windows, no porch lights. There is only the instrument, the calculation, the fuel, the weather, and the hope that the next decision is the right one. So when people hear that compasses may behave strangely in the Bermuda Triangle, the story lands in a very old part of the mind. It says, What if north is not north? What if the one thing that should guide you refuses to agree with the map? What if you're not just lost, but unable to know how lost you are? These are powerful questions, even when the scientific answer is calmer. The answer is not that the triangle destroys direction. The answer is that direction has always been more complicated than most passengers realise. There is also a lesson here about certainty. A compass provides a direction, not a guarantee. A map provides a representation, not the sea itself. A radio provides communication if it works. A forecast provides probability, not a promise. Navigation is the art of making all these partial tools agree well enough to move safely through the world. In the Bermuda Triangle, the legend grew around moments when that agreement seemed to fail. Sometimes because of real confusion, sometimes because of later exaggeration, sometimes because the final evidence was missing, and missing evidence has a way of making every theory feel invited. The magnetic mystery, then, is not best understood as a giant invisible force lurking between Florida, Bermuda, and Puerto Rico. It is better understood as a collection of real navigational challenges made famous by repetition and fear. Earth's magnetic field is real. Declination is real. Magnetic north moves. Compass correction matters. Instruments can be misunderstood. Human beings can make errors. Open water gives few second chances. Place all of that inside a famous triangle, and the result is a story that feels larger than its parts. And perhaps that is why the compass remains one of the most lasting symbols of the Bermuda Triangle. It sits at the boundary between science and instinct. Science tells us how the needle works, why it points where it does, and how to correct for its difference from true north. Instinct tells us that a confused compass means trouble. Both are useful in their own way. The science keeps us from inventing monsters when none are needed. The instinct reminds us not to treat direction casually. By now, the idea of magnetic confusion has become so tangled with the triangle that it is hard to separate fact from mood. The facts are manageable. Compasses point to magnetic north, not usually true north. Declination varies by location and time. Navigators must correct for it. The agonic line is where that correction is zero. Earth's magnetic field changes, so models like the World Magnetic Model are updated for modern navigation. The mood is different. The mood is a pilot hearing uncertainty in his own voice. A sailor watching a needle and not liking what it says. A search team plotting possible positions across too much water. A family hearing that the last known direction may not have been reliable. That is where the Bermuda Triangle story keeps its hold. Not in the claim that magnetism explains everything, because it does not. Not in the image of compasses spinning like nervous clock hands, because that is more legend than evidence. It holds because navigation is a fragile agreement between tools, training, environment, and judgment. When that agreement breaks, the ocean does not need to become supernatural. It only needs to be large. And once direction becomes uncertain, the next danger often arrives from above rather than below. A compass can guide a route, but it cannot calm the sky. A chart can mark a passage, but it cannot stop warm air from rising, storms from forming, or visibility from closing around a pilot at the wrong time. Many of the triangle's most practical explanations begin not with magnetism, but with weather, the ordinary, measurable, and sometimes violent force that can turn a familiar route into a very different place, before anyone has quite finished believing the day is safe. Weather is one of those explanations that can sound almost too ordinary at first. It does not arrive with the satisfying strangeness of a magnetic portal, a lost civilization, or a secret doorway under the waves. It is not dramatic in the way legends prefer, at least not until you are inside it. From a safe room, with a roof above you and a mug on the table, bad weather can sound like a background detail. A storm passed through, visibility dropped, winds increased, seas became rough. These phrases are easy to read and even easier to underestimate. But to a pilot over open water or a sailor watching the horizon darken, Weather is not background. It is the environment changing its mind around you. The Bermuda Triangle sits in a part of the Atlantic where weather has many ways to become difficult. Warm ocean water, tropical air, sea breezes, thunderstorms, squalls, waterspouts, hurricanes, and fast-moving local changes can all belong to the same broad neighbourhood. Not every day is dangerous, of course. Most days are not. Many crossings through the region are calm, ordinary, and so uneventful that the most memorable part may be a delayed sandwich or a sunburn someone insisted would not happen. But the region has the ingredients for sudden trouble, and sudden trouble is exactly the kind that grows legends. A calm surface can be misleading. The ocean does not always announce its plans far in advance. A morning can begin with soft light, mild wind, and water that looks flat enough to polish. Then clouds build. The air feels heavier. A line of rain appears in the distance. Wind shifts, waves steepen. A small boat that felt comfortable an hour earlier begins to feel very small indeed. A pilot looking down at friendly blue water may soon be looking at cloud layers, rain shafts, turbulence, and a horizon that is no longer easy to separate from the sea. Weather does not need to be historic to be dangerous. It only needs to be strong enough for the craft, crew, and situation in front of it. This is important because popular versions of the Bermuda Triangle often skip over ordinary weather as if ordinary weather could not possibly explain extraordinary fear. But weather is one of the most powerful forces on Earth. It moves ships, grounds, aircraft, floods cities, closes ports, damages engines, blocks visibility, and changes decisions. It can turn a confident journey into a calculation of survival. The fact that it can be measured does not make it gentle. A thunderstorm does not become polite because meteorologists understand it. It remains a tall, moving engine of wind, water, electricity, and unstable air, and it is very much capable of ruining someone's afternoon, or far worse. The Atlantic hurricane season officially runs from June 1st through November 30th, and the Atlantic basin includes the Atlantic Ocean, the Caribbean Sea, and the Gulf region. That does not mean every Bermuda Triangle story involves a hurricane. Many do not. It also does not mean that the region is dangerous only during those months. But it places the triangle near a seasonal system of risk that sailors, pilots, insurers, forecasters, and coastal residents take seriously. Tropical storms and hurricanes are large, organised, and often tracked carefully. But the ocean does not wait until a storm has a famous name before it becomes hazardous. Lesser systems, thunderstorms, squall lines, and local gusts can still create very real trouble. The National Weather Service notes that wind gusts from thunderstorms over water can be dangerous to small boats at 30 miles per hour, or 26 knots, and greater. It also describes downbursts as powerful sinking air beneath thunderstorms, a hazard that can be especially dangerous to aviation during takeoff and landing. Those numbers deserve a little attention because they sound modest if you hear them while sitting still. 30 miles per hour is not a hurricane. It may not even sound like a storm worth cancelling a barbecue over, though your paper plates may disagree. But out on the water, wind is not just wind. It pushes against hulls, builds waves, changes handling, creates spray, and makes small mistakes harder to correct. For a small vessel, especially one already dealing with engine trouble, poor visibility, or uncertain position, a strong gust can be the difference between manageable and dangerous. Downbursts and microbursts are another piece of the weather puzzle. A microburst is a localized column of sinking air within a thunderstorm, usually no more than 2.5 miles wide, but capable of causing damaging winds when the air hits the surface and spreads outward. To an aircraft, this can be a serious hazard, because it can change wind conditions rapidly. A plane may encounter a sudden shift from headwind to downdraft to tailwind, which affects lift and performance. Near landings and takeoffs, this has been a major aviation safety concern. Over open water, the exact situation differs, but the principle remains unsettling. air that looks like empty space is not empty at all. It can move violently, downward and outward, with little concern for the assumptions in a cockpit. Now, imagine trying to tell that story after the fact if the aircraft is gone and the weather records are incomplete. A strange disappearance may become a mystery, because no one survived to describe the sudden gust, the turbulence, the rain, the disorientation, or the chain of decisions that followed. Later, people may look at the absence and ask why there was no clear distress call. But in fast-changing weather, a crew may have little time to explain. Aviating, navigating, communicating. Pilots are taught these priorities for a reason. First, keep the aircraft flying. Then know where it is going. Then tell others. In a worsening situation, a long calm message for future historians may not be available, which is inconsiderate of emergencies but very common of them. For boats, sudden weather can be just as punishing, though in a different way. A small vessel that loses power in calm water may drift, radio for help, or wait. The same vessel losing power and building seas has a much harder problem. Waves can turn the boat broadside. Water can come aboard. Equipment can break loose. Crew can become exhausted or injured. Visibility can fall. A radio antenna can be damaged. A bilge pump can fail. Each issue may be survivable alone, but weather encourages problems to meet one another. It is very sociable in that unfortunate way. Waterspouts add another visual element to the fear. NOAA explains that waterspouts usually develop over warm tropical ocean waters and that they are seen in the Florida Keys more than any other place in the world. The National Weather Service describes waterspouts as tornadoes over water, with both tornadic and non-supercell types, and notes that a mature waterspout may have a spray ring at the surface. A waterspout is not the explanation for every Bermuda Triangle disappearance, not even close. But it belongs to the region's real weather vocabulary. It is a reminder that the line between ordinary cloud and dangerous rotating column can sometimes be much thinner than a calm postcard suggests. There is a particular unease in seeing dangerous weather over beautiful water. A thunderstorm over an industrial harbour already looks serious. A thunderstorm over turquoise sea can feel almost unfair. The colour of the water suggests holiday. The sky suggests caution. The mind receives mixed messages. This contrast has helped the Bermuda Triangle legend in ways that are easy to understand. The region is famous for islands, beaches, clear water, and warm light. It is not a place people instinctively file under danger, so when danger appears there, it seems to violate the setting. A storm in a dark northern sea feels expected. A storm over bright tropical water feels like a betrayal, which is perhaps unfair to weather, because it never promised to behave for photographs. Tropical weather also has scale. A hurricane can affect a vast region, and even if its centre is far away, swells, outer bands, wind shifts, and deteriorating seas can matter. The National Hurricane Center issues outlooks and discussions for tropical systems, because these systems can develop, strengthen, weaken, curve, stall, and surprise people who stopped paying attention too early. Mariners and pilots do not only worry about where a storm is, they worry about where it will be, how quickly conditions are changing, and whether the planned route remains safe. A forecast is not a guarantee. It is a skilled estimate of a changing system, and changing systems are famous for being rude to confidence. Before modern forecasting, this was even more difficult. Many of the famous Bermuda Triangle stories come from eras when weather satellites were unavailable or limited. Aircraft weather radar was not what it is today. Communication was weaker, and forecasting over open ocean was less precise. Today we can watch clouds from space, track storms with aircraft, satellites, buoys, radar, models, and ship reports. Earlier crews had less warning. A vessel might leave with the best information available and meet weather that had changed faster than expected. A pilot might enter conditions that looked manageable at first, and then lose visual references, radio clarity, or position confidence. When later investigators look back, the weather may be one of the most likely suspects, but not always one that leaves fingerprints. That is one of weather's great advantages as a mystery maker. It can do damage and then move on. A reef remains. A mechanical defect may be found in wreckage. A cargo problem may be traced through records, but a squall passes, a downburst ends, a thunderstorm cell collapses. The sea may remain rough for a while, then smooth out as if nothing happened. By the time search crews arrive, the sky can look innocent, the ocean can look calm. People may wonder how such a peaceful place could have taken anything at all. Weather is very good at leaving the scene. The Gulf Stream complicates this further. NOAA describes the Gulf Stream as a powerful current, fastest near the surface, with typical maximum speeds of about 5.6 miles per hour and an average speed around 4 miles per hour. That may not sound fast compared with a car, but for an ocean current moving vast amounts of water, it is serious. Wind against current can create rougher, steeper seas. Floating debris can be carried away from a wreck site. A search area can shift. If a storm or squall damages a vessel or aircraft and debris enters the water, the current can help separate the evidence from the location of the event. A mystery that began in the sky can become a problem of water movement. This is where the Bermuda Triangle becomes less like a single cause and more like a machine made of many moving parts. Warm water helps create unstable air. Thunderstorms create gusts, downdrafts, lightning, rain, and rough seas. Currents move vessels and debris. Visibility changes. Navigation becomes harder. Communication may become strained. If a craft is small, old, overloaded, poorly maintained, low on fuel, or crewed by people who are tired or inexperienced, the risk rises quickly. No one part of that system needs to be bizarre. The combination is enough. In aviation, weather can also create spatial disorientation. This is a plain phrase for a frightening experience. When a pilot cannot see the horizon clearly, the body's sense of motion can become unreliable. The inner ear can mislead. A bank may not feel like a bank. Level flight may feel wrong. Climbing, descending, turning, and accelerating can create sensations that do not match the instruments. Instrument training exists because the body is not a dependable flight instrument, despite having served us reasonably well when walking to the fridge. Over water, where visual references are few, clouds, haze, darkness, and rain can make disorientation more likely if a pilot is not properly trained, equipped, or focused. A famous phrase in aviation is continued VFR into IMC, which means a pilot flying under visual flight rules continues into instrument meteorological conditions, where visual references are no longer sufficient. This has caused many accidents around the world. The Bermuda Triangle does not own this problem. It is not even especially original in this regard. But the region's open water, islands, sudden showers, haze, and storms can create conditions where visual confidence fades. If a pilot becomes uncertain while also dealing with navigation problems, fuel limits, or communication issues, the situation can deteriorate. The same is true at sea with visibility. Rain can erase distance. Night can reduce the world to instruments, lights, and sound. A squall line can hide land, buoys, or other vessels. A small craft may lose sight of a channel marker or mistake one light for another. In shallow areas with reefs and banks, poor visibility can be dangerous. In deep open water, it can turn a route into guesswork if equipment is unreliable. The weather does not need to sink the boat directly. It can make the crew make a worse decision. That is often how disasters work. They are not single blows. They are traps set by conditions. Lightning is another concern, though it is often less discussed in triangle legends because it is too normal to be exciting. Lightning can damage electronics, radios, navigation systems, and electrical components. A strike at sea or in the air can be serious, depending on the circumstances. Modern aircraft are designed to withstand lightning strikes, and many do, but equipment problems can still occur. Smaller boats may be more vulnerable. A damaged radio or navigation system during worsening weather is exactly the kind of practical problem that later becomes mysterious, because no one hears the rest of the story. Rain itself can be a hazard beyond simple discomfort. Heavy rain reduces visibility, affects radar interpretation, fills small boats, makes decks slippery, and can accompany downdrafts and gust fronts. In aircraft, heavy precipitation can create turbulence, reduce visibility, and signal convective activity that pilots prefer to avoid. A cloud is not just a cloud when it is part of a thunderstorm. It is a structure with rising air, sinking air, electrical activity, water droplets, ice, and changing winds. From outside, it may look like a grey wall. Inside, it may be a very poor place to take a shortcut. This is another reason the Bermuda Triangle legend can mislead. It encourages people to imagine a unique danger inside the triangle, but weather hazards are widespread. Thunderstorms occur in many places. Hurricanes affect large parts of the Atlantic basin. Waterspouts occur beyond the triangle too. Downbursts and microbursts are not Bermuda specialists with tiny passports. The real question is not whether these hazards exist only there. They do not. The question is how they interact with the region's traffic, routes, currents, geography, and history of reported incidents. The triangle is not frightening because it has weather no other place has. It is frightening because weather there can meet open water, heavy traffic, and difficult search conditions. There is also the human problem of believing the weather should behave according to plan. People like schedules, ships have arrivals, flights have fuel planning, passengers have expectations, cargo has deadlines, training flights have routes, private boaters have hotel bookings and dinner reservations. Weather does not care about any of this. It will not delay a thunderstorm because someone has already paid for a non-refundable room. That mismatch between human planning and atmospheric reality is a quiet source of risk. People may continue longer than they should because turning back feels inconvenient, embarrassing, expensive, or unnecessary. Then the situation changes, and the earlier decision becomes much more important. In many accidents, the weather is not a surprise in the absolute sense. It may have been forecast, it may have been visible, it may have been building. The surprise is how quickly it becomes unmanageable for the particular craft and crew involved. A strong vessel with experienced crew may pass through conditions that would overwhelm a smaller boat. A well-equipped aircraft with trained pilots may handle weather that would be dangerous for another pilot in another machine. Weather risk is not only about the storm, it is about the meeting between the storm and the traveller. A wave does not have to be huge in general, it only has to be too much for the boat it finds. This makes the phrase, weather that turns without warning, slightly complicated. Sometimes weather truly does change quickly. Small storms can build, gusts can arrive, visibility can collapse, and waterspouts can form with less notice than anyone would like. Other times, there are warnings, but they are missed, misunderstood, underestimated, or overtaken by events. In the legend, the weather often seems to turn like a villain. In reality, the turn may be a chain of observations and decisions, some of which only look obvious afterward. Hindsight is very good at weather forecasting, which is easy for hindsight because it arrives after the storm. To scientists and investigators, weather is not a vague excuse. It is something to reconstruct carefully. They look at reports, pressure, wind, satellite data when available, ship observations, aircraft communications, radar records, sea state, storm tracks, and the timing of distress or disappearance. Sometimes weather clearly explains an incident, sometimes it contributes, sometimes it is uncertain. But it is almost always worth asking about because weather changes the operating environment. It can turn manageable problems into urgent ones. A failing engine in calm weather is one kind of emergency. A failing engine in a squall is another. A navigation error in clear daylight is bad. A navigation error in rain and low cloud can be much worse. The public, however, often prefers explanations that feel less ordinary. There is a reason sudden violent weather and navigational difficulty does not travel as far as mysterious force field. One sounds like a report, the other sounds like a trailer, but the report is where the danger usually lives. The strongest scientific answer to the Bermuda Triangle is not that nothing dangerous happens there. It is that the danger is made of recognizable things: weather, currents, navigation, equipment, human limits, and the difficulty of finding evidence afterward. Recognizable does not mean harmless. It means we can study it, reduce risk, and still respect it. The frightening thing about weather in the Bermuda Triangle is that it does not need to be rare. It can be part of the ordinary operating environment. Thunderstorms are ordinary, squalls are ordinary, tropical systems are seasonal, waterspouts are known phenomena. The Gulf Stream is a known current, but when ordinary hazards occur in a place already associated with disappearance, they take on a different feeling. A rainstorm becomes atmosphere, a gust becomes a clue, a waterspout becomes a suspect, a hurricane track becomes part of the legend. This is how the triangle turns weather into memory. At the same time, weather reminds us why the wildest stories are not necessary. The natural world already has enough power. A small boat in a strong thunderstorm does not require a curse. A pilot losing visual references does not require a portal. Debris carried away by current after rough weather does not require a vanished dimension. Nature is more than capable of producing events that feel impossible to people waiting safely on land. The gap between what happened and what can be proved later is where the legend grows. So when we think about weather in the Bermuda Triangle, we should not imagine a permanent storm waiting in the middle of the map. That is not how the region works. Most of the time, the sky is just sky. Flights pass, ships move, tourists arrive, fishing boats return. People take photographs of sunsets that are not ominous at all, just orange and pleasant and perhaps a little overshared. Then, on some days, the atmosphere changes. Clouds build, wind rises. A shower becomes a wall, a manageable sea becomes confused, instruments become more important, decisions become heavier. The same place that felt easy becomes demanding. This is the practical terror of weather. It does not make the Bermuda Triangle uniquely cursed. It makes the ocean honestly dangerous. It shows how quickly confidence can be tested and how little room there may be for error when the nearest solid ground is far away. It also explains why some disappearances leave so few clues. A storm can damage, scatter, sink, and erase. A current can carry, deep water can hide. By the time the story reaches land, what remains may be only the route, the time, the names, and the word missing. That word has done more for the Bermuda Triangle than any storm ever could. Missing. It turns weather from an event into a question. If the wreckage is found and the cause is clear, weather becomes explanation. If the wreckage is not found, weather becomes possibility. And possibility is where legends are most comfortable. From here, the story moves naturally into another set of scientific suspects, because weather is not the only natural force people have tried to place beneath the triangle's reputation. Some explanations come from the sea itself. Gas rising from the ocean floor, waves that appear larger than expected, currents that move with great strength, and ocean conditions that can damage vessels before anyone understands what has happened. Some of these ideas are plausible in certain contexts. Some have been stretched far beyond the evidence. All of them show the same thing in different ways. The Bermuda Triangle does not need one impossible secret when the real ocean already contains enough strange and powerful behaviour to keep investigators busy. After weather, the Bermuda Triangle story tends to sink below the surface, where the explanations become heavier, colder, and in some cases a little more dramatic than they first appear. This is the part of the mystery where science and speculation begin walking side by side, not always at the same speed, and not always with the same destination in mind. Some ideas are based on real natural forces. Some are possible in certain places but not proven for the famous triangle cases. Some sound scientific because they use good scientific words, but once you look closely, they begin to wobble like a folding chair at a family picnic. One of the most famous scientific suspects is methane. Not just ordinary methane floating around in the air, but methane hydrate, sometimes called fire ice, which is an ice-like solid made of water and methane gas. It forms in places where pressure is high and temperature is low, especially in sediments beneath the seafloor along continental margins. USGS describes gas hydrate as something that forms naturally when water combines with certain gases under low temperature and moderate pressure conditions, with methane being the gas most often trapped inside it. This is real science. Methane hydrates are not invented for television specials. They exist, they are studied, and they matter to geology, climate research, and energy discussions. They just may not be the tidy master key that unlocks every Bermuda Triangle disappearance, which is inconsiderate of them really, after being given such a dramatic role. The theory usually goes something like this. Methane trapped beneath the seafloor is suddenly released. Large amounts of gas bubble upward through the water. Those bubbles reduce the density of the water near the surface. A ship passing through that disturbed patch may lose buoyancy, sink rapidly, and leave little time for distress calls. In some versions, methane gas then rises into the air and interferes with aircraft engines, causing planes to crash as well. It is an attractive idea because it sounds natural, powerful, and unusual. It gives the triangle a hidden mechanism. No monsters required, just geology having a very bad day. At first glance, the ship part has a certain logic. Ships float because they displace water. If the water beneath a ship was suddenly filled with enough gas bubbles, the support from that water could change. The vessel might sit lower, become unstable, take on water, or sink. Experiments and discussions have explored whether gas bubbling can reduce buoyancy enough to affect a vessel, and the idea is not completely absurd in a narrow physical sense. But the trouble is scale, timing, evidence, and location. To sink a large ship quickly, the release would need to be very large, very sudden, and very close to the vessel. It would also need to happen at the right moment, under the right conditions, and then leave little evidence. That is a lot to ask of bubbles, even ambitious ones. A smaller vessel might be more vulnerable than a large ship, but even then, the event would have to be extreme. Normal seafloor gas seepage is not enough. A few bubbles rising through the water are not going to swallow a cargo ship like a bathtub drain. They may disturb sediments, feed microbial communities, or create interesting research opportunities for oceanographers, but they are unlikely to make a vessel vanish in the grand theatrical manner that the legend suggests. Nature can be dramatic, yes, but it is also quite fond of details, and the details matter. For aircraft, the methane idea becomes even more difficult. A plane would need to encounter a large concentration of methane in the air, at the right altitude and location, in a concentration that could affect engine performance or combustion. That is not impossible in every imaginable scenario, but it is not something that has been clearly tied to the famous Bermuda Triangle cases. It also does not explain navigation confusion, radio silence, weather, fuel loss, structural problems, or the many different circumstances involved in different disappearances. This is one of the problems with grand theories. They may explain one narrow kind of accident in theory, and then people try to make them explain everything from a missing tanker to a training flight to someone's uncle's fishing boat, which is asking quite a lot from one geological process. There is also a geographic issue. Methane hydrates are known in many places around the world. USGS notes that most methane hydrate deposits globally are found below the seafloor, at water depths greater than about 300 to 500 metres on continental margins. If methane hydrates alone made a region into a vanishing zone, we would expect many other continental margin areas to collect similar legends with equal force. Some have their own maritime dangers, of course, But they do not all become Bermuda Triangles. That tells us the legend is not only about geology, it is about traffic, storytelling, missing evidence, media attention, and the human habit of turning clusters of events into shapes. A 2014 discussion reported by Live Science and Southern Methodist University covered claims linking methane gas explosions to Bermuda Triangle vanishings, but scientists quoted in that coverage treated the idea cautiously, with one calling it an interesting theory rather than a proven explanation. That is often where the best version of the methane theory belongs. Interesting, worth understanding, physically grounded in some ways, but not demonstrated as the cause of the famous disappearances. It is a suspect with a real address, not a convicted criminal. This is a good moment to remember a useful rule for mysteries. A real phenomenon is not automatically the right explanation just because it sounds impressive. Lightning is real, but it does not explain every house fire. Sinkholes are real, but they do not explain every missing car. Bubbles are real, and methane hydrates are real, but that does not mean every missing ship in the western North Atlantic was taken by a gas release. Scientific explanations must match the evidence of each case. They need timing, location, mechanism, and consistency. Without those, they become stories with scientific furniture. Then there are rogue waves, which are another kind of scientific suspect, and a much more immediately frightening one for sailors. NOAA describes rogue waves, also called extreme storm waves by scientists, as waves greater than twice the size of surrounding waves, very unpredictable, and often arriving unexpectedly from directions other than the prevailing wind and waves. That definition is unsettling enough without any help from legends. A ship may be handling rough seas, and then one much larger wave arrives at the wrong angle, with steep sides and a deep trough, and suddenly the sea is not just rough. It is dangerous in a way the crew may not have expected. For a long time, rogue waves lived partly in sailor stories. Enormous waves had been reported, but reports from exhausted crews in dangerous weather were sometimes treated with doubt. That changed as measurements and modern observation confirmed that unusually large sudden waves do happen. The ocean is not a flat set of repeating ripples. Waves interact with wind, current, storms, and each other. Under certain conditions, wave energy can focus, and one wave can become much larger than the surrounding sea. To anyone on a vessel in its path, this is not folklore. It is a wall of moving water with a very poor attitude. Rogue waves are especially appealing as a Bermuda Triangle explanation because they can damage or sink vessels quickly. A large enough wave striking a ship badly can break windows, flood compartments, damage equipment, roll smaller craft, or overwhelm a vessel already struggling in bad conditions. Unlike a hurricane, a rogue wave may not leave a broad weather system that everyone can point to afterward. It may be part of rough seas, but its exact moment can be hard to reconstruct. If no one survives, the wave leaves no witness. If the ship sinks in deep water and debris scatters, the evidence may be minimal. For a legend built on sudden disappearance, rogue waves fit the mood very well. But once again, fit is not proof. Rogue waves are real, and they may explain some maritime losses somewhere, perhaps even some losses in or near the triangle, but they do not explain aircraft disappearances. They do not explain radio confusion before a plane runs low on fuel. They do not explain every missing vessel, especially those lost in conditions that may not have supported such waves. They are part of the ocean's danger, not a universal solution. A rogue wave is not the Bermuda Triangle wearing a wave costume. It is one real hazard among many. The Gulf Stream may help create difficult seas in some situations. NOAA notes that the Gulf Stream's surface velocity can reach about 5.6 miles per hour, with an average speed around 4 miles per hour, and that the current transports more water than all the world's rivers combined. A strong current meeting wind or waves from another direction can create rougher, steeper, more confused seas. It can also move debris far from where a vessel or aircraft went down. This matters because the lack of wreckage is one of the triangle's strongest emotional ingredients. If wreckage is not found where people expect it, the mind begins to reach for stranger explanations. But in a moving ocean, evidence does not wait neatly at the scene. Imagine a search team working from a last known position that may already be uncertain. Add hours of delay, add wind, add current, add floating debris that moves at different speeds depending on shape, weight, and exposure above the water. Add sinking debris that goes straight down or drifts before it sinks. Add deep water, waves, and bad visibility. The search area expands. The clean dot on the map becomes a wide, restless region. If nothing is found, it feels like the object vanished, but it may have sunk, drifted, broken apart, or moved outside the search zone. That is not satisfying, but the ocean is not required to be satisfying. It has other priorities, mainly being enormous. Another suspect sometimes mentioned is the sudden failure of the seafloor itself. Submarine landslides can occur when sediments on the ocean floor become unstable and slide downslope. Gas hydrate can be associated with seafloor sediments, and USGS notes that hydrate breakdown can release methane and water into surrounding sediments, increasing internal pressure. This can prime slopes for failure if triggered by something like an earthquake or too much sediment, though USGS also states there is no evidence that gas hydrate itself causes seafloor failures. This is a careful scientific distinction, which means it's exactly the kind of sentence that gets shortened badly in popular retellings. Hydrates may prime slopes under certain conditions, becomes gas ice opens the seafloor and eats ships, and from there, the poor facts are already waving goodbye from the dock. Seafloor landslides can matter in the ocean. They may affect cables, disturb sediments, generate local water movement, and in some settings contribute to tsunamis. But again, using them to explain the Bermuda Triangle requires actual evidence for a specific event. Was there a landslide at the right time and place? Was a ship above it? Was the water depth appropriate? Was there seismic activity? Did records show anything? Without that, it remains a possible natural process, not a confirmed explanation. The sea floor is not perfectly still, but it is also not a trapdoor waiting under every unfortunate vessel. Some people bring up underwater volcanoes, earthquakes, or sudden gas eruptions as broad explanations. These are real geological phenomena in the world, but the Bermuda Triangle is not generally treated by scientists as a unique geological danger zone that explains its reputation. NOAA states that there is no evidence mysterious disappearances occur more frequently there than in other large, heavily travelled areas of ocean, and that the US Navy and US Coast Guard do not accept supernatural explanations for disasters at sea. The useful point is not that geology is irrelevant, it is that extraordinary geological claims need more than a frightening map and a confident narrator. Then there are equipment failures, which may sound dull until you remember that equipment is what keeps people alive in difficult conditions. An engine failure far offshore is not a small matter. A steering failure, electrical fault, fuel contamination, leaking hull, malfunctioning bilge pump, damaged radio, faulty compass, or failed navigation system can turn a routine trip into an emergency. On aircraft, mechanical problems may involve engines, instruments, radios, electrical systems, fuel systems, or structural issues. These are not exotic, but they are serious. A mechanical problem in clear weather near a runway is one thing. A mechanical problem over open water in poor visibility is another. The machine and the environment cannot be separated. The Bermuda Triangle legend tends to hide maintenance behind mystery. It focuses on the moment of disappearance, because that is where the suspense lives. But investigators often look backward. They ask what condition the vessel or aircraft was in before departure. Were repairs needed? Was the cargo loaded correctly? Was the crew trained? Were safety rules followed? Was the aircraft fit for the route? Was the boat too small for the conditions? Was the fuel sufficient? Were the radios working? Did anyone ignore warnings? These questions are not glamorous. They also save lives. A mystery may begin at sea, but its cause may have been sitting in a checklist hours earlier. Human error is another suspect, and perhaps the most uncomfortable one. People do not like to say it, especially when lives were lost, because it can sound like blame. But human error does not always mean carelessness. It can mean fatigue, stress, poor information, bad visibility, confusing instruments, wrong assumptions, incomplete training, pressure to continue, or a decision that seemed reasonable at the time. Over open water, the cost of ordinary error can be high. A wrong heading, delayed turn, misunderstood radio call, fuel miscalculation, or failure to turn back soon enough can become fatal. Human fallibility is not a moral failure. It is a design feature of our species, along with curiosity, storytelling, and the ability to lose sunglasses while wearing them. This is why the Bermuda Triangle remains useful as a study in risk. It gathers many hazards that are not unique on their own, but become powerful together. A storm, a current, a compass correction, a tired pilot, a weak radio, an old ship, a dangerous cargo, a wave, a bad forecast, a missing distress call, a delayed search. Any one of these might be manageable. Several together can become disaster. The legend looks for one hidden cause beneath the water. Real accidents often come from chains. There is a phrase used in accident investigation called the Swiss cheese model. The idea is that defences against disaster are like slices of Swiss cheese. Each slice has holes, but the holes are in different places. Usually one layer catches what another misses. But when the holes line up, a hazard passes through every layer and an accident happens. The Bermuda Triangle is often imagined as one giant hole in reality. A more careful view suggests many smaller holes: weather, navigation, maintenance, communication, training, equipment, geography, search difficulty. When enough of them align, a journey can fail in a way that later looks mysterious. This is also why some scientific suspects are appealing but incomplete. Methane gives the legend a hidden seafloor cause. Rogue waves give it sudden violence. The Gulf Stream gives it moving evidence. Mechanical failure gives it practical weakness. Human error gives it decision points. Weather gives it changing conditions. None of these alone has to explain the whole legend. Together they explain why the region can produce frightening stories without needing the supernatural. The fear is not that science has no suspects. The fear is that science has many, and several can arrive together. A vessel struck by a large wave may lose power. Without power, it may drift into worse seas. A damaged radio may prevent a distress call. The Gulf Stream may move debris. If the last known position was uncertain, search crews may look in the wrong place. Later, the case is remembered as a ship that vanished without a trace. Each link is natural. The final story feels unnatural because the links are missing from public memory. The same can happen with aircraft. A pilot encounters weather, becomes uncertain of position, trusts a mistaken assumption, burns fuel while trying to correct, loses communication, or gives unclear reports, then goes down in rough seas. If wreckage is not found, the legend keeps only the silence. It says the aircraft disappeared. Technically, yes. Emotionally, the word suggests a clean and impossible removal from the world. In reality, the aircraft may have followed a chain of ordinary failures into a place where evidence was hard to recover. The scientific suspects also show how easily the Bermuda Triangle story borrows credibility. Real science gives us methane hydrates, rogue waves, ocean currents, storm systems, magnetic variation, and human factors. The legend takes those real things and sometimes stretches them until they cover more than they should. This is not unusual. Popular mysteries often survive by mixing genuine facts with large assumptions. The genuine facts keep the story from floating away completely. The assumptions give it wings, or perhaps fins, depending on the evening. A careful listener can hold both ideas at once. Methane hydrates are real, but not proven as the cause of the famous vanishings. Rogue waves are real, but not an all-purpose answer. The Gulf Stream is real and can move debris, but it does not sink ships by itself. Weather is real and dangerous, but not every loss happened in a documented storm. Human error is real, but not every case gives enough evidence to know what people did wrong. Mechanical failure is real, but without wreckage, sometimes it cannot be confirmed. The honest answer is often less tidy than the legend and more useful than the myth. That may be the hardest part of the Bermuda Triangle for people to accept. We want one reason. We want a final reveal. We want the moment when the investigator turns from the wall of maps and says, "Of course, it was this all along." But the ocean does not always provide that kind of ending. It gives partial records, damaged evidence, delayed searches, and conditions that change before anyone can measure them. The truth may be different for each case. Some losses may be weather, some navigation, some mechanical, some structural, some human, some unknown, but not therefore impossible. Science, at its best, does not remove fear by pretending nothing bad happens. It gives fear a shape. It says, here are the hazards, here are the limits, here is what we can measure, here is what we cannot know, here is where a popular theory is plausible, here is where it fails. That is calmer than legend, but not weaker. In fact, it is stronger, because it does not need to force every disappearance into the same box. It lets each event be studied on its own terms. So the scientific suspects beneath the Bermuda Triangle are not a line of villains waiting to confess. They are a crowded room of possibilities. Methane sits there looking dramatic but unproven. Rogue waves sit there looking very real and very dangerous, but not universal. The Gulf Stream sits there quietly moving the evidence while everyone argues. Weather leans against the wall, having already done a great deal of work in the previous part. Human error and mechanical failure sit near the door, familiar and uncomfortable. Deep water says very little, because deep water does not need to explain itself, and perhaps that is why the mystery remains so difficult to sink. Not because it has no explanation, but because it has too many partial ones, each useful in some cases, none able to carry the whole legend alone. The Triangle has become a place where real hazards are gathered under one famous name. Some are physical, some are psychological, some belong to the sea. Some belong to us, and once a name becomes famous enough, even good explanations do not always make it disappear, because the next question is no longer simply what happened out there. It is why we keep returning to the story, why the mystery survives correction, and why a region crossed safely every day can still feel, in the public imagination, like a warning drawn over blue water. The strangest thing about the Bermuda Triangle may not be that people once believed it was unusually dangerous. The strangest thing may be that the belief is still alive after so many careful explanations have been offered, printed, debated, corrected, and quietly placed on the table like a sensible cup of tea. NOAA states that there is no evidence mysterious disappearances happen more often in the Bermuda Triangle than in any other large, well-travelled part of the ocean, and Britannica notes that the phrase Bermuda Triangle itself only entered popular use in 1964, after Vincent Gaddis used it in an Argosy magazine article, and yet, here we are. The name still works, the map still feels charged, the old stories still gather listeners. The moment someone says Bermuda Triangle, people do not usually think, ah yes, a statistically disputed maritime legend in a busy region of the western North Atlantic. They think of vanishing planes, empty seas, strange instruments, and the unpleasant possibility that the world may still have pockets where ordinary explanations arrive late and slightly out of breath. That is worth paying attention to. A mystery does not survive for this long, simply because people have not heard the skeptical view. Many have. They know the broad arguments, they know the area is busy, they know weather, navigation, human error, currents, and mechanical failures can explain a great deal. They may even know that the triangle has no official fixed boundary, which makes counting incidents inside it a rather slippery exercise, like trying to count sheep while the sheep are allowed to redraw the fence. And still, the story does not go away. It does not sink under the weight of correction. It floats. It keeps floating because the Bermuda Triangle is not only a question about what happened to certain ships and planes, it is also a question about how human beings handle uncertainty. Uncertainty is uncomfortable. Not always loud, not always dramatic, but persistent. When something bad happens and we know why, the mind has somewhere to put it. A storm caused it. A part failed. Someone made a wrong turn. A hull was weak. Fuel ran out. The explanation does not remove the loss, but it gives the loss edges. It allows the event to become part of a sequence. This happened, then that happened, then the result followed. A disappearance without a clear ending refuses to take that shape. It stays open. It becomes a room with the light off, and even if someone tells us there is probably only furniture in there, some part of us still imagines movement. The Bermuda Triangle is full of these dark rooms, not because every case is equally mysterious, and not because all the famous stories were told accurately, but because the best-known incidents share a feeling of incompletion. A vessel leaves and is not found. A plane communicates and then falls silent. A search begins and returns with little. Records do not answer everything. Weather reports are incomplete, or wreckage is missing, or the final decision in a cockpit or on a bridge is forever unknown. Investigators may have likely explanations, but likely is not the same as witnessed. Probable is not the same as seen. And the public imagination, which has never been known for its patience with incomplete paperwork, steps into that space and begins building. This is one reason the mystery refuses to sink. It is not only defended by believers, it is fed by missing endings. A solved accident becomes a cautionary tale, an unsolved disappearance becomes a legend. That difference matters. If a ship sinks in a storm and wreckage is found, the story may remain sad, but it usually does not grow tentacles. If a ship disappears and the wreck is never located, the story can keep changing shape for generations. People can add theories because there is no physical evidence strong enough to stop them. The sea, by hiding the last page, allows many people to write their own. The ocean is very good at this. It hides evidence more efficiently than most places on land. It moves debris with currents. It sinks heavy material into depth that may be difficult or expensive to search. It breaks objects apart. It damages records, bodies, cargo, and machines. It can turn a search area from difficult to absurdly large in only a few hours. That alone gives the Bermuda Triangle an advantage as a legend. A mystery in the ocean can stay mysterious because the ocean is not an archive. It does not preserve things neatly in folders. It does not label wreckage and leave it beside a buoy with a polite note attached. It takes, moves, buries, scatters, and corrodes. Then from the surface, it may look calm. This calmness is part of the problem. Disasters at sea often leave no visible scar. A field where an aircraft crashed may bear marks. A road accident may leave glass, skid marks, photographs, witnesses, and reports. But the ocean can close over an event so completely that the next morning a traveller passing through the same area might see only sunlight on waves. This creates a strange emotional mismatch. If a place looks peaceful after a loss, the loss feels even harder to understand. People expect danger to leave signs. In the Bermuda Triangle, the sign is often only absence. Absence is powerful. It makes people listen harder. A final radio call can be replayed again and again. A last known position can be circled on maps. A missing distress signal becomes a question. A lack of wreckage becomes, in some retellings, almost more important than wreckage would have been. This is not quite logical, but it is human. We are drawn to gaps because gaps ask us to participate. They invite us to imagine the missing pieces. A complete report can be read and filed away. An incomplete one keeps tapping on the window. The Bermuda Triangle also survives because it has a very good shape. That sounds almost silly, but it matters. A triangle is easy to remember. It has 3 points, 3 sides, and a clean inside. Even if the actual borders are disputed and unofficial, the idea feels tidy. Miami, Bermuda, Puerto Rico. A line here, a line there, and suddenly the Atlantic has a frame. The frame gives the story a sense of order. It turns scattered incidents into something that looks like a pattern. Without the shape, many of the losses might remain separate tragedies. With the shape, they become clues. People love patterns. We are built to find them. In many cases, that ability keeps us alive. A rustle in tall grass may be wind, but if it might be a predator, noticing patterns quickly is useful. The trouble is that our pattern-making system does not always know when to stop. It can connect events that are only loosely related. It can treat coincidence as design. It can make a famous region feel more dangerous simply because the famous cases are easier to remember than the thousands of ordinary journeys that pass through safely. This is sometimes called availability bias. The easier an example is to recall, the more common or important it may feel. A dramatic disappearance is memorable. A normal landing is not. No one gathers the family around to say, "Good news, another plane crossed the Atlantic and nothing strange happened." Though perhaps airlines would enjoy the applause. The Triangle's reputation feeds on this imbalance. Safe crossings disappear from memory almost instantly. Lost ships and aircraft remain. They are named, retold, filmed, exaggerated, corrected, and retold again. Over time, the rare event becomes the identity of the place. This is not unique to the Bermuda Triangle. Many places are known for their dangers more than their ordinary life. A mountain becomes famous for climbers who did not return, even though many did. A road becomes known for accidents, even though most drivers pass safely. A beach becomes known for shark attacks, even though millions enter the water without incident. Fear remembers exceptions. Routine has poor publicity. Media helped the Bermuda Triangle become more than a collection of incidents. The phrase gained public force after the 1964 article by Vincent Gaddis, and later books and television programs carried the idea much further. Once the story entered popular culture, it became self-reinforcing. A new audience learned the name. Writers found older cases and placed them inside the pattern. Television added music, maps, cloudy reenactments, and narrators who sounded as if they had personally offended the Atlantic. The story became entertainment, and entertainment does not always move at the same speed as careful investigation. This does not mean every storyteller acted in bad faith. Many were fascinated, as people naturally are, by unresolved loss. But popular mystery has a tendency to polish the strange parts and leave the dull parts in the drawer. A case with weather complications, maintenance concerns, navigation errors, and uncertain testimony can become, after enough retelling, a perfectly good ship vanished in calm seas. A pilot's confusion can become instruments failed for no reason. A lack of wreckage in deep, moving water can become no trace could exist because something impossible happened. Each simplification makes the story easier to remember and less accurate. By the time corrections arrive, the legend has already found a comfortable chair. Corrections also face a problem. They are often less emotionally satisfying than the mystery. A person who has heard for years that the Bermuda Triangle may involve alien visitors, time warps, Atlantis, magnetic disturbances, or a secret force under the waves may not feel rewarded by hearing, actually, many incidents likely involved weather, navigation, poor reporting, vessel condition, or ordinary accident rates. That answer is sensible. It may even be true, but it does not sparkle in the same way. It is hard for a fuel miscalculation to compete with a portal. It is hard for marine insurance statistics to compete with a vanished squadron. Reality often wears comfortable shoes, while mystery arrives with a cape. There is also a personal reason the triangle stays frightening. It deals with travel, and travel is a form of trust. Every journey begins with an assumption. I will leave here and arrive there. We make this assumption constantly. We trust roads, rails, engines, wings, hulls, maps, crews, schedules, and weather forecasts. Usually this trust is rewarded so regularly that we stop noticing it. We become annoyed by delays rather than amazed by arrival. The Bermuda Triangle interrupts that ordinary confidence. It reminds us that departure and arrival are connected by systems that can fail. That reminder is uncomfortable because it applies beyond the triangle. A person does not need to cross the Bermuda Triangle to understand the fear of being between places, between airport and runway, between coast and island, between takeoff and landing, between last message and no answer. The triangle gives that fear a location. It turns a general human worry into a specific patch of ocean. That makes it easier to discuss and harder to forget. Another reason the mystery survives is that science itself is sometimes misunderstood as a machine for producing complete certainty. People hear an expert say there is no evidence for a supernatural Bermuda Triangle, and they may think science is claiming to know exactly what happened in every case. It is not. Science can say the broad legend is unsupported. It can say disappearances are not proven to be unusually frequent there. It can say natural and human factors explain many incidents better than paranormal theories. But it may still leave some individual cases unresolved because evidence is missing. That partial uncertainty can be used by believers as a doorway. They say, "But you do not know for sure," and in some cases that is true. We do not know for sure. But not knowing for sure is not the same as every explanation being equally likely. This is a subtle point, and it matters very much. Unknown does not mean unknowable magic. Unexplained does not mean unexplainable. A missing wreck does not mean a ship entered another dimension. It may mean the wreck is deep, scattered, mislocated, or never searched with the right tools. But because science is honest about uncertainty, legends can sometimes borrow that honesty and bend it. The careful phrase, "we cannot determine the exact cause," becomes, in public memory, "no normal cause is possible." Those are very different sentences. One is cautious, the other is selling tickets. The Bermuda Triangle also benefits from being just plausible enough at the edges. The wildest claims may be unsupported, but the region does contain real hazards: storms, currents, reefs, shallow banks, deep water, heavy traffic, and historically challenging navigation. NOAA's explanation emphasizes that foul weather and poor navigation can make the ocean deadly anywhere, including the Triangle. This means skeptics cannot simply say, "Nothing dangerous happens there." Dangerous things do happen there. They happen in many oceans, but they still happen. That gives the legend raw material. A completely safe place cannot easily become terrifying. A genuinely hazardous but not uniquely cursed place can. This middle ground is where the Triangle lives most comfortably. It is not empty nonsense. Real people were lost. Real searches failed. Real weather occurs. Real navigation problems have happened. Real ships and planes have disappeared. But the leap from real losses to a single mysterious force is where the evidence weakens. The mystery refuses to sink because the first half of the story is true enough to keep the second half alive. Ships did vanish. Planes were lost. Wreckage was sometimes not found. People did wonder. The problem is what gets added after that. The public also has a complicated relationship with experts. When official agencies say the Triangle is not unusually dangerous, some people find that reassuring. Others find it suspicious. There is a long tradition in mystery culture of treating official explanations as cover stories, not conclusions. If the Navy, Coast Guard, NOAA, or insurers do not see a supernatural mystery, that may be because there is no supernatural mystery. Or, in the more imaginative version, because they know too much and are hiding it behind very calm language. This is how conspiracy thinking protects itself. Evidence against the theory becomes part of the theory. A denial becomes proof that the truth is being suppressed. At that point, the mystery has built itself a life raft. It helps that the Bermuda Triangle does not require one belief. Different people can bring different fears to it. Someone interested in aviation may focus on Flight 19. Someone drawn to shipwrecks may think of Cyclops or Marine Sulfur Queen. Someone who likes geology may talk about methane. Someone fascinated by the ocean may talk about rogue waves. Someone who enjoys paranormal stories may reach for aliens, Atlantis, or time slips. Someone skeptical may talk about statistics and bad reporting. The triangle can hold all of them because it is more of a cultural container than a single theory. It is a place where many explanations compete without one needing to win completely. That flexibility makes it durable. A mystery with only one claim can be damaged if that claim fails. A mystery with many claims can survive by shifting attention. If compasses are explained, talk about weather. If weather explains one case, bring up a different case. If a case is debunked, mention an older one with poorer records. If statistics weaken the region's reputation, focus on emotional impact instead. The Bermuda Triangle is not one locked door. It is a hallway of doors, and people keep opening whichever one feels most interesting that day. The name itself has become shorthand. It now describes more than geography. People use it casually to mean any place where things vanish. Lost socks, missing pens, emails no one can find, the drawer where phone chargers go to form secret governments. This everyday use keeps the legend alive in a small way. Even when people are joking, they repeat the name. Repetition is powerful. It keeps the triangle in language long after many people stop believing the strongest claims. A story does not need full belief to survive. Sometimes it only needs familiarity. Childhood plays a part too. Many people first heard about the Bermuda Triangle when they were young, perhaps in a library book, a television special, a classroom conversation, or from someone who enjoyed sounding mysterious at family gatherings. Childhood mysteries are sticky. They attach to the imagination before skepticism is fully built. Later, as adults, we may learn the more practical explanations, but the original feeling remains in the background. A person can know the closet is empty and still remember being afraid of it. Knowledge updates the mind. It does not always erase the atmosphere. That atmosphere is important to the triangle. It is not just what people believe, it is how the subject feels. Warm seas, empty horizons, static on a radio, a compass needle, a search plane flying low over water, a family waiting, a ship overdue. These images are simple and they work. They do not require detailed argument. They create a mood before facts arrive. Once a mood is strong enough, facts have to work harder. This is not a failure of intelligence. It is how storytelling functions. We are not computers sorting evidence in neat columns. We are animals with memory, fear, pattern recognition, and an unfortunate weakness for dramatic maps. The mystery also refuses to sink because it offers a rare modern version of the old unknown sea. Much of the world now feels measured. Satellites image the planet. Phones show our location. Aircraft are tracked. Weather systems are modelled. Ships use GPS. Maps update in our pockets. In such a world, it is strange and almost thrilling to imagine a place where things can still vanish. The Bermuda Triangle gives the ocean back a little of its old power. It says, even now, with all your instruments and screens, there are still places where an answer may not come easily. That idea can be frightening, but also strangely attractive. It may be especially attractive because we do not want the world to be completely explained. We say we do, particularly when something scares us. But a fully explained world can feel smaller. Mysteries keep distance in the landscape. They allow the imagination to breathe, though sometimes it breathes directly into a paper bag. The Bermuda Triangle lets people feel that the map still has a warning written in invisible ink. It offers wonder, dread, and argument in equal measure. For a story, that is a very healthy diet. There is another reason explanations fail to end the legend. Many explanations are case-specific, while the legend is general. An investigator can explain one disappearance or suggest the likely cause of another, but the public may still ask about the triangle as a whole. The legend gathers cases under one name, while science often takes them apart. This creates a mismatch. Science says, let us examine each event separately. Legend says, look how many events there are. Science says, This one involved weather. Legend says, what about the others? Science says, that one had navigation issues. Legend says, still strange. The conversation can continue forever because the two sides are not always answering the same question. The better question may not be, is the Bermuda Triangle real? That question is too blunt. The region is real. The name is real. The disappearances were real, at least in many famous cases. The supernatural reputation is not supported by strong evidence. The statistical danger is disputed and often rejected by experts. The cultural power is undeniable. So the better question is, what kind of thing is the Bermuda Triangle? It is not an official danger zone. It is not a proven scientific anomaly. It is a folklore machine built from real geography, real loss, incomplete evidence, dramatic retellings, and human discomfort with uncertainty. Calling it folklore does not mean calling it foolish. Folklore is one way people process risk. Sailors, pilots, miners, climbers, soldiers, and travellers have always told stories about danger. These stories warn, entertain, exaggerate, remember, and sometimes distort. The Bermuda Triangle is modern folklore shaped by 20th century aviation, shipping, media, and science. It uses radios instead of lanterns, aircraft instead of wooden ships, and magnetic anomalies instead of sea gods. But the function is old. It gives fear a place to live. That place remains useful because the ocean still deserves respect. Even if the triangle is not uniquely deadly, the conditions people associate with it are serious. Weather can turn, instruments can confuse, boats can fail, aircraft can run low on fuel, currents can move evidence, deep water can hide wreckage, people can make mistakes. Most of the time, training and technology keep these risks under control, but not always. The Bermuda Triangle's legend may exaggerate the region, but it does not invent the vulnerability of travellers over open water. In that sense, the mystery survives because it points to a truth larger than itself. We are safer than we used to be, but not invulnerable. We know more than we used to know, but not everything. We have better tools than earlier generations, but tools are not guarantees. The old disappearances remind us of a world with fewer signals, poorer forecasts, weaker navigation systems, and larger unknowns. The modern listener hears those stories from a different age, but the emotional core still makes sense. To be lost is still frightening. To wait for someone who does not arrive is still unbearable. To look out over water and know it may hold answers no one can reach is still enough to quiet a room. So the Bermuda Triangle refuses to sink because it is supported from below by many things at once. Incomplete records, real tragedies, flexible geography, strong imagery, media repetition, human pattern making, fear of disappearance, distrust of official certainty, genuine ocean hazards, childhood memory, the pleasure of mystery, the discomfort of not knowing. Remove one and the story remains. Remove another and it still floats. It is less like a ship and more like a raft made of many small pieces, each one keeping part of the legend above water. And perhaps that is why it continues to terrify even people who know the skeptical arguments. Not terror in the sense that scientists are hiding under desks whenever someone says Bermuda. More a quieter form of unease. The kind that comes from knowing the natural world is powerful enough without needing help from fantasy. The kind that comes from realizing that some questions remain open, not because the answer is magical, but because the evidence is gone. The kind that comes from seeing how easily a journey can become a story, and how easily a story can outlive the facts that began it. The Bermuda Triangle is not frightening because science has failed. It is frightening because science, at its most honest, sometimes has to say, this is the most likely explanation, but we may never know every detail. That sentence is mature, careful, and deeply unsatisfying to the part of us that wants the final page. Legends flourish where final pages are missing, and the triangle has had many missing pages. By now we have moved through the map, the weather, the compass, the waves, the currents, the gas, the machines, the human choices, and the stories laid over all of them. What remains is not a single monster hiding in the Atlantic, but a clearer understanding of why the name still has power. It is a reminder of how easily fear can gather around real events, how quickly a map can become a myth, and how the sea can turn ordinary journeys into questions that last longer than anyone expected. The final part of this voyage is not about proving the triangle harmless or declaring it solved with a neat little bow. It is about standing back from the whole strange history and asking what the Bermuda Triangle really teaches us about science, fear, and the deep human need to make sense of silence. And so, after all the maps, the missing flights, the quiet ships, the compass needles, the storms, the waves, the currents, and the scientific suspects lined up one after another like nervous guests at a very damp dinner party, we return to the simple question that brought us here in the first place. Why does the Bermuda Triangle still frighten us? Not just interest us, not just entertain us, frighten us. Because there is a difference. Interest sits forward in its chair. Fear stays awake after the lights are off. The easy answer would be to say that people are frightened because they do not understand the facts. But that is not quite fair. Many people do understand the facts, at least in broad outline. They know the triangle is not officially fenced off by science as a supernatural zone. They know that pilots and sailors cross the region safely every day. They know that the ocean is full of routes, schedules, cargo, radar, GPS, radio systems, weather models, and very practical people wearing very practical shoes. They may even know that official agencies do not treat the Bermuda Triangle as a place where nature behaves in a special paranormal way. NOAA says there is no evidence that mysterious disappearances happen there more often than in other large, well-travelled ocean regions, and yet the old feeling remains. That feeling does not come only from ignorance. It comes from scale. It comes from silence. It comes from the fact that a human life can be very carefully planned and still pass through conditions too large to control. A ship can have a destination. A plane can have a flight plan. A crew can have training. A passenger can have luggage waiting in the overhead compartment. But the sea is still the sea. The sky is still the sky. Weather still changes. Engines still depend on parts. Instruments still depend on power, calibration, and interpretation. People still become tired, confused, hurried, or unlucky. A route can be familiar, and still become dangerous when enough ordinary problems arrive at once. The Bermuda Triangle frightens us because it takes modern confidence and places it over deep water. That may be the most honest explanation of all. It is not that the triangle proves the supernatural, it is that it reminds us how thin our sense of control can be. We live in a world where almost everything seems trackable. We can open a phone and see a blue dot showing where we are. We can watch aircraft move across digital maps. We can check storms from satellites. We can follow ships, read forecasts, send messages, and look at images of almost any coast on Earth. It is easy to feel as if the map has been completed. It is easy to believe that nothing truly vanishes anymore. But then we remember that things still do. Not often compared with the number of safe journeys. Not usually in the strange way the legend suggests. But still, sometimes a vessel is overdue. Sometimes a signal stops. Sometimes a search area grows too large. Sometimes wreckage is not found. Sometimes the final minutes are reconstructed from fragments, probabilities, weather, fuel, and the last words anyone heard. Even in a technological age, the world still contains gaps. The Bermuda Triangle has become one of the names we give to those gaps. That name carries weight because it is simple. Bermuda Triangle, 3 words, clean, easy to remember, easy to draw. It sounds like a place with edges, even though its edges have never been official or fixed. It sounds almost like a warning on a chart, though it began as a story built in public imagination. The phrase became widely known after Vincent Gaddis used it in 1964, and once a name like that enters culture, it becomes more than geography. It becomes a container. Into it go old losses, new theories, half-remembered documentaries, school library books, late-night conversations, and the quiet thrill of hearing that something may still be unsolved. But what have we really found in that container? We found the ocean first, not a flat blue space on a map, but a moving environment with currents, shallow banks, deep channels, reefs, sudden changes, and long distances. We found the Gulf Stream, strong enough to move water and debris far from where people might expect them to remain. NOAA describes the Gulf Stream's surface speed as fastest near the surface, with maximum speeds typically around 5.6 miles per hour and an average speed around 4 miles per hour, which is slow for a car but very serious for an ocean current carrying evidence away from a search area. We found weather, not as a boring footnote, but as one of the main reasons the sea has always required respect. Storms, squalls, water spouts, wind shifts, rain, low visibility, and rough water can turn a normal trip into a dangerous one. Weather does not need to be the largest storm in history to matter. It only needs to be too much for the vessel or aircraft that meets it. A small boat, a tired crew, an old engine, a poor forecast, a wrong decision, and a sudden squall can create a story that later sounds much stranger than it was. We found compasses and the uncomfortable truth that direction is not always as simple as a needle pointing north. Magnetic north and true north are different things. Declination changes by place and time. Navigation requires correction, training, and care. A compass does not have to spin in circles to contribute to danger. It can be steady and still be misunderstood. It can be correct while the navigator's larger assumption is wrong. That is a quieter kind of fear, and perhaps a more realistic one. We found rogue waves. Real waves, not folklore, greater than twice the height of surrounding waves, unpredictable, and sometimes arriving from directions that do not match the prevailing wind and seas. NOAA describes rogue waves as extreme storm waves that can appear suddenly and unexpectedly. For sailors, that is enough to make the ocean feel less like a surface and more like a place that can still surprise even experienced people. A rogue wave may not explain every Bermuda Triangle loss. It does not explain missing aircraft or every famous case, but it reminds us that the ocean can produce sudden violence without needing a legend to help it. We found methane too. Methane hydrates are real. Gas can be trapped beneath the seafloor under certain conditions. The idea that a sudden release could affect buoyancy has been discussed for years. But a real phenomenon is not the same as a proven explanation for the famous disappearances. Science asks for evidence at the right time, in the right place, with the right mechanism. The triangle legend often asks only for a dramatic possibility. That is the difference between investigation and storytelling. We found machines, ships that may have had structural weaknesses, aircraft that may have faced fuel, radio, weather, or navigation problems, vessels that carried difficult cargo, engines, instruments, batteries, radios, hulls, wings, tanks, wires, pumps, and bolts. These are not glamorous things, but they are the bones of survival. When they work, no one thinks about them. When they fail, the world can become dangerous very quickly. And we found people. That may be the part most legends handle too quickly. People in the cockpit, people on deck, people at radios, people waiting in ports and homes, people reading instruments, making decisions, trusting training, correcting course, watching weather, calculating fuel, and trying to get back safely. The Bermuda Triangle story often turns them into evidence, but they were not evidence. They were human beings. Some were trained professionals, some were passengers, some were sailors doing ordinary work, some were families expecting a normal arrival. To speak about the triangle properly, we have to remember that the mystery is not only about missing machines, it is about missing lives. That is why the story should not be treated only as entertainment, even though it has often been sold that way. Behind the eerie music and the dramatic maps were real losses. Real people did not come home. Families waited for answers that may never have arrived. Investigators worked with limited evidence. Search crews looked across enormous areas of water and sky. It is easy, years later, to speak of cases and incidents, but each one was once a present tense emergency. A phone call not received, a dock left empty, a seat at a table not filled. The Bermuda Triangle is not frightening because every story about it is true. Many are exaggerated, some details have been repeated badly, some incidents have been pulled into the triangle even when the connection is loose. The borders have shifted, the numbers have sometimes been inflated, the facts have not always been treated gently. But the triangle still frightens us because the best skeptical answer is not, nothing happened. Something did happen, many things happened. The better answer is, the things that happened do not require one supernatural cause. That is a useful answer, but not always a comforting one, because the natural explanations are still serious. Bad weather is serious. Deep water is serious. Navigation error is serious. Mechanical failure is serious. Human uncertainty is serious. A moving current that carries wreckage away is serious. A search area too large to cover properly is serious. These are not little explanations. They are not weak explanations. They are the actual forces that have challenged travellers for as long as people have crossed water. The Bermuda Triangle asks us to look at a familiar modern world and remember that it still sits inside nature. Airports, ports, maps, engines, satellites, and radio towers are remarkable. They reduce danger, they make long journeys normal, they make the world feel smaller, but they do not remove the ocean. They do not remove weather. They do not remove distance. They do not remove the fact that a small mistake can become large when there are no landmarks and no safe place to stop. Maybe that is why the triangle remains more frightening than many purely supernatural stories. A ghost ship can be dismissed. A sea monster can be laughed away. A time portal can be placed politely back into fiction. But weather, fuel, current, depth, confusion, and silence cannot be dismissed so easily. They are real. They have happened before. They will happen again somewhere, because the world is not built around human convenience. We plan routes through it, but we do not own the conditions. There is also something about the location that keeps the fear alive. The Bermuda Triangle is not at the end of the earth. It is not an impossible place. It is near Florida, Bermuda, Puerto Rico, the Bahamas, the Caribbean, busy routes, airports, ports, beaches, and places people visit for pleasure. That closeness matters. A mysterious zone in a remote polar sea would feel distant. The Bermuda Triangle feels reachable. It sits near holiday waters, cruise routes, fishing grounds, and flight paths. The same region that appears in postcards can appear in disappearance stories. That contrast gives the legend its chill. A beautiful place can still be dangerous. Clear water can still hide depth. Warm air can still build storms. A calm morning can still become an unsafe afternoon. The Bermuda Triangle reminds us not to confuse beauty with safety. The ocean can be both. It can be peaceful and dangerous, ordinary and overwhelming, familiar on the map and difficult in person. That is not a contradiction. That is the sea. This is also why the mystery does not disappear when experts explain it. Experts can explain many pieces, but they cannot make the ocean feel small. They can describe currents, waves, storms, navigation, and statistics. But the emotional fact remains. Open water is humbling. The explanation may be correct, and the fear may still make sense. Fear is not always proof of danger, but sometimes it is recognition. It recognizes scale. It recognizes limits. It recognizes that being human means moving through systems bigger than ourselves. So what should we do with the Bermuda Triangle now? We do not need to worship it as a supernatural trap. We do not need to pretend that every missing vessel was pulled into a hidden world beneath the waves. We do not need aliens, Atlantis, or a hole in time to make the story worth telling. But we also do not need to flatten it into nothing. It is not nothing. It is a cultural memory built from real journeys, real losses, real hazards, and real uncertainty. It is one of the ways the modern world remembers that the sea is still not fully tame. Perhaps the most useful way to see the Bermuda Triangle is as a warning about stories themselves. It shows how quickly facts can become legend when they are incomplete. It shows how a name can gather events together and make them feel connected. It shows how missing evidence can become more powerful in public imagination than evidence found. It shows how people can hear a careful explanation and still prefer the version with shadows around the edges. And it shows how science and mystery are not always enemies. Sometimes science is the tool that lets us approach mystery without being swallowed by it. Science does not ruin the Bermuda Triangle. It changes the shape of the fear. Instead of a magic place where ships vanish for no reason, we see a busy region of ocean where real-world hazards can overlap. Instead of one impossible force, we see many possible failures. Instead of a curse, we see weather, water, distance, machines, decisions, and the limits of evidence. The story becomes less supernatural but not less human, and human is where it has always lived. We are the ones who draw the triangle. We are the ones who name the water. We are the ones who remember the missing. We are the ones who look at a map and feel something more than geography. The sea itself does not know it is inside a legend. The waves do not change behaviour because someone made a television special. The Gulf Stream does not carry debris away more mysteriously because the word triangle appears in a title. The region simply exists, moving as ocean moves, while we bring our fear, curiosity, grief, and need for meaning to it. That need for meaning is not foolish. It is part of how people survive loss. When something disappears without a clear answer, the mind keeps reaching. It reaches for causes, patterns, clues, memories, warnings, and sometimes impossible explanations. A mystery can be a way of refusing to let the missing become only absence. It keeps asking where they went. It keeps the names moving through time. It keeps the story from closing too quickly. But there is a gentle responsibility in that. We can be curious without being careless. We can speak of the Bermuda Triangle without turning every lost person into a prop for a spooky tale. We can enjoy the mystery while respecting the facts. We can admit uncertainty without filling every gap with fantasy. We can let the ocean be powerful enough as it is, and it is powerful enough. It does not need secret gates. It does not need hidden civilizations. It does not need invisible hands pulling ships below. It has wind, depth, pressure, waves, currents, darkness, corrosion, distance, and time. It has weather that can change a route. It has water deep enough to keep wreckage out of reach. It has current strong enough to move clues. It has enough size to make even large machines seem small. The real ocean is already more than strange enough. By now, if you have stayed with this journey from the first quiet mention of the triangle to this final look across its long reputation, you may feel that the mystery has changed. It may not look like a doorway anymore. It may look more like a mirror. Not a magical mirror, just the ordinary kind that shows us something true if we stand still long enough. The Bermuda Triangle reflects our fear of being lost. It reflects our dependence on machines. It reflects the limits of memory and evidence. It reflects the way stories grow when facts are missing. It reflects our uneasy respect for the sea, and maybe that is why it has never fully gone away. Because every generation has its own version of that fear. Earlier sailors feared storms, reefs, and empty horizons. Early aviators feared fuel, weather, and navigation over open water. Modern travellers may trust satellites and systems, but even now, the idea of vanishing between departure and arrival still reaches something old in us. We want the route to finish. We want the signal to continue. We want the map to be enough. We want the people who leave to come home. Most of the time, they do. That should be remembered too. The Bermuda Triangle is crossed safely again and again. Flights land, ships dock, families reunite, cargo arrives, tourists complain about luggage, crew members finish shifts, boats return before sunset. Ordinary life keeps moving through the same waters that legend has darkened. This matters because fear can make exceptions look like the whole truth. They are not. The whole truth includes all the safe passages as well. Still, the old name remains. It waits in books, documentaries, online videos, and childhood memory. It appears whenever something disappears in a drawer and someone jokes that it must have gone to the Bermuda Triangle. It survives because it is useful language for a certain kind of absence. The kind that feels too complete. The kind that makes us search twice. The kind that makes us wonder whether the world has kept something from us. So, as we leave these waters tonight, perhaps the best answer is not that the Bermuda Triangle is solved or unsolved. It is that it is understood differently depending on how closely we look. From far away, it looks like a dark legend drawn over blue water. Closer in, it becomes a collection of separate events, many with practical explanations and some with missing details. Closer still, it becomes a study of weather, navigation, machinery, currents, and human decision-making. And closest of all, it becomes a reminder that uncertainty is part of being alive in a world much larger than ourselves. That may not be the dramatic ending some people want. There is no final monster rising from the water, no hidden island appearing in the mist, no secret switch under the Atlantic turning compasses around. There is only the sea, the sky, and the long record of people trying to cross them safely. There is science doing its careful work. There are stories doing their stubborn work. And between them, there is the Bermuda Triangle, still famous, still questioned, still less supernatural than rumour suggests, and still more serious than a simple joke. So let me ask you gently once more, wherever you are listening from tonight, are you near the ocean or far from it? Can you hear traffic outside, rain on a window, a fan in the room, the quiet sound of a house settling into night? It is strange to think that while you are here, safe in your own small place, ships are moving through dark water somewhere. Aircraft are crossing long routes. Weather is forming and fading. Currents are carrying warm water northward. The world is continuing, full of motion, full of systems, full of trust. And if this quiet voyage through one of the world's most famous mysteries has brought you a little curiosity, a little calm, or even just a useful respect for the next weather forecast, I'd be very grateful if you liked the video, subscribed, and shared this space with someone else who enjoys strange questions answered gently. The Bermuda Triangle may not be the supernatural trap it was once imagined to be, but it still teaches us something worth keeping. It teaches us that the unknown does not always vanish when we explain it. Sometimes it becomes clearer, more human, and more connected to the real world beneath our feet and beyond our shorelines. For now, the map can rest, the compass can settle, the waves can keep moving without needing us to solve every shadow beneath them. You are here, not lost, not drifting, not waiting for a signal, but simply listening at the edge of sleep while the old story fades back into the water. Sleep well, fellow traveller, wherever you are tonight, and if your dreams take you over the Atlantic, may the skies stay clear, the instruments stay steady, and may every journey find its way home.